Good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So, guys, today is the most awaited session of production. So, today we are going to have all the topics related to production technology, and we will be having revision of formulas for all the topics. And there are some topics which were not covered in the marathon series, like metal forming, sheet metal operations, computer integrated manufacturing. So for them, we will be going with the theory as well. Means we will be not only looking at the formulas for those topics, but we will revise it completely like it should be in a marathon session. Okay. Yes, Hemang, Akshita, Ayush, Jamit, Avinash, Deepshikha, Malesh, everyone. Good morning, guys. So we are starting the session. Please tell me, am I properly audible and visible to all of you or not? So as I said, for the topic like metal forming, sheet metal operations, yes, for such type of things, sheet metal forming. For these topics, we will go in detail, okay? And for the other topics for which the marathons have been completed, like metal cutting, like you already know, casting, welding, I have taken just before marathon series. For those topics, we will see only the formulas, okay? So we will try to cover it within 2 to 3 hours so that it should not take much time. The reason is I don't want to waste your time much because if I would be keep on revising the same thing again and again, it will waste your time, as now after 2-3 days you have the exam, okay? So guys, let us continue the session. Let us start the session. So guys, this is some detail about me. I feel every day we are meeting, so you are aware of all this. And guys, this is Mechanical by Dheeraj Sardana is a Telegram channel where you will be getting the PDF of this session and many others. And you will also get all the important updates, daily questions, doubt clarification, everything. Okay guys. So now one more thing is like there is a session on machine design, that is top 10 question. Okay, I will be taking it tomorrow. In the morning time only. Actually it is scheduled for tonight, but tonight may not be possible, so we will take tomorrow in the morning only, so you can join that session also. This will be the last session in the prediction series. Moving further, guys, so you know, whenever your exam is going to be there on 4th February, just after your exam, when you will be coming out from the examination center, we will join you live, okay, where we will be telling you about the examination level, how it was, the type of questions what have been asked, and also the solution of the questions. If you want to ask about the cutoffs, yes, we can tell you about expected cutoffs, expected topper marks, expected rank, all those things we will discuss on that day, okay? So now we are starting, guys. So we are starting with the metal forming. As I know you guys were saying for this topic quite long. Yes, we will be going in a faster manner to save your time also. So when we are talking about the metal forming operations, guys. So metal forming operations, in this there are 3 things which are there in the syllabus of GATE. One is we need to see the bulk metal forming operations. Other is sheet metal operations, and third one is powder metallurgy. So when we are talking about this topic, this is a very, very important topic. The weightage goes somewhere around 4 to 5 marks. Okay. And one question comes from the bulk metal forming operation for sure. One question comes from sheet metal operation for sure. So 2 questions are coming from these 2 topics. From here, every year question are not coming. From powder metallurgy, question may be there once in 3 years, once in 4 years, like that. Okay. So guys, now when we are talking about the bulk metal forming operation, as the name suggests, here the metal is going to be deformed in the bulk. And here when we are talking about bulk metal forming, there are 4 operations we are going to study here. One is rolling, other is extrusion, third is wire drawing, fourth is forging. And when we are talking about all these 4 operations, here whatever the stress is induced in the material, they are going to be more than the yield strength, and they are going to be less than the ultimate strength. What do you mean by that? It means we are going to fail the material but not fracture. Failure of material will happen here, but fracture will not happen. So we are going for the permanent failures where material will be deformed permanently. So definitely some permanent strain will be there in the material. So guys, here loading will be such that stresses are more than yield but less than ultimate. And you know, ductile material shows both yield and ultimate strength. Brittle material shows only ultimate strength. So it means these operations are majorly done on the ductile materials. Then my dear, when we are talking about the sheet metal operation, we are classifying them in the two categories. The first one is sheet metal forming. The second one is sheet metal cutting operation. Sheet metal forming operations are those in which once again the induced stress will be more than SYT but less than SUT. So it means here also the fracture will not happen, and in this we are having deep drawing and bending. Then we have sheet metal cutting operations. In sheet metal cutting operation, we have the stresses induced to be more than ultimate. Here actually shear failure happens. So in this category we have blanking, we have punching, and punching is also known as piercing. Okay. So guys, in this we can also have one more operation, that is cutting, where we are directly cutting somebody. So all these are coming under sheet metal operations. Then we will have a powder metallurgy discussion. Powder metallurgy is an operation when we are making the components made up of powders. There we will be mixing the powders of metal in the desired composition. Then we will compact them in the shape of dies. And after that, we will be going for sintering process to make the bondings in that, and we will make the component. Yes, Priyanka, hi dear. So guys, please quickly tell me, are you getting everything? Am I going with the right speed? That is fine for all of you. So guys, this is about the metal forming operation. Now my dear, before we go further, I feel, yes, now we will be talking about, just wait. Yes. So now my dear, as you know, whenever I have shown you the types of operation here, the most important operation is a rolling, because majorly questions are coming from the rolling. But before we enter into that, we will have a quick discussion on one thing, that is said to be hot working and cold working operation. That is said to be hot and cold working operation. I feel everybody will be aware of these hot and cold working operations. When we are talking about hot and cold working operations, what is that actually? So my dear, whenever we are going to have our working temperature to be more than recrystallization temperature, then it is said to be hot working. And if we have our working temperature to be less than recrystallization temperature, then we will be calling it as cold working. So when we are talking about hot working and cold working, it is depending on recrystallization temperature, whether the working temperature is more than that or less than that. Recrystallization temperature is a temperature where new crystals are going to start forming. And guys, when we are talking about this recrystallization temperature generally lies between 0.4 to 0.6 times of melting point temperature. So in this, definitely at recrystallization temperature, melting do not happens, only new crystal formation happens. How it is possible? Because at higher temperature, degrees of freedom of molecules, ions, atoms is going to be more. So my dear, when we are talking about hot working and cold working, there are different advantages and disadvantages. When we are going for hot working, as you are providing the heat, because of heat material is getting softening, we need to apply lesser amount of forces, power consumption is lesser. When we are going for cold working, you are not going to heat the workpiece, it is in colder condition, you need to apply more forces, more work done, more power. When we are going for hot working, you know that every material has a property, on heating it expands, on cooling it contracts. So my dear, because of that, whenever we are talking about hot working, we will never be getting good dimensional accuracy, because you are going to work at higher temperatures. So when you will be going for the work, after that, whenever you will come to the room temperature, contraction will happen. So size and shape will once again change. So because of that, we will never get the desired shape and size. Some you can say disturbances will be there because of those expansion and contractions. And guys, that's why in hot working we do not get good dimensional stability. Good dimensional accuracy. In cold working, we are going to get that. When we are talking about the hot working, then my dear, hot working is requiring higher temperature. So because of that, the entire setup should be such that it can bear that high temperature. Whereas in cold working, when we are talking about, there we are working at generally room temperatures. So my dear, because of that, as we are working at lower temperature, the entire setup is made up of normal material. We do not require a material which can withstand high temperature. So definitely for hot working, setup cost is going to be very, very high as compared to others. Then the last point is metals at higher temperature are very reactive towards oxygen. They make metal oxides. So because of that, hot working will give you poor surfaces, whereas cold working will give you good surfaces. I feel with this everybody is aware of this. And also I would like to tell you one very important point on the next slide. So when we are going to have this stress strain diagram for mild steel, I feel everybody would be aware of two very important points. You are saying this to be SYT, this to be SUT. And you know our working is going to happen in this region only. So we are also calling this region to be the plastic deformation zone. And this is the region in which the metal forming is going to work. So guys, majorly our work is going to be in this region. And this is said to be plastic deformation zone. So when we are going for hot working, it is going to reduce the yield strength of the material. And when we are going for cold working, it is going to increase the ultimate strength of the material. So how it happens, we will discuss that also. So when this is the reason, this is the things are going to happen. It means whenever we are going for hot working or cold working, either we are reducing the yield strength, means we are going to the left, or we are increasing the ultimate strength, we are going to the right. It means somewhere we are trying to increase the zone of working. So somewhere we are trying to increase the zone of working. That is what we are looking for in hot working and cold working. Okay. So our target here is to increase plastic deformation zone. Yes, we know there is something called as warm working also. Something called as warm working also. In warm working, we are going to use the benefits of both hot and cold working. Is it clear? Please tell me till this point everybody is clear or not. Then just wait, I am going to the right slide to start the rolling operation, and we will be now continuing with the one by one. We will continue with the all operations like rolling, forging. So is it clear for everyone? Shall we start now? Yes. Okay guys. Fine. So we will be starting with the rolling now. We will be starting with the rolling now. We will be starting with the rolling now. Yes. So guys, you know what happens in the rolling operation. So I will be showing you the rolling operation. Then we have all the formulas for that. Whenever we are talking about the rolling operation, first of all, we are having this operation that is said to be rolling. Okay. So in the rolling operation, yes. Sir, in plane strain rolling process for average rolling force, formula some faculty says force 3 and some 2 times average thickness, which is right. Dear, I didn't get your question. If you have that kind of thing, do share it with me either on Telegram or on the WhatsApp. Then I will be able to get what you are saying. Please share the situation where different faculties are saying differently. Please show that. So guys, this is the rolling process. You know, here we are having this workpiece material which is having some thickness of H0. Okay. And guys, you are going to reduce this thickness. And obviously, if you want to see the dimension, it is having some width B also. And guys, when we are talking about this, these are the two rollers. They are the centers of the roller. This roller is rotating in this direction. This roller is rotating in this direction. Okay. And it is similar to the process you have seen at the time of sugarcane juice. So whenever sugarcane juice is taken, then also between two rollers, we are going to pass the sugarcane. But dear, their juice is coming from the sugarcane. Here we are talking about metal forming. So rolling of metal will not give you any amount of juice for sure. That is why the reduction will also not be very high. So here, my dear, let us say H1 is the thickness after the process. So my dear, initially it is H0, finally it is H1. So definitely thickness is getting reduced. So my dear, whenever we are talking about the rolling process, you can understand that when we are passing this material from the rollers, when the thickness is getting reduced, obviously length will be getting increased. Some people would be thinking, sir, what about width? So guys, it is our assumption, and it have been seen also that the changes in width are very limited. So guys, that is why whenever we are talking about B initial and B final, it is said to be equal. So this is our assumption also, because changes are very, very less. So guys, that is why we are assuming the strain in this dimension is going to be negligible. That's why TPM was saying about the plane strain condition. Okay. So guys, when we are assuming that, second assumption is we are assuming the initial volume to be equal to the final volume. So what is initial volume? You know that this is going to be B naught, H naught and L naught, which can also be written as B1, H1 and L1. You know B naught and B1 are equal. So guys, from here you can write that H naught by H1 is equals to L1 by L naught. Now what we are doing, we are dividing them by the time. Dividing by time will give you the velocity. So it is going to be V1 by V naught. So guys, from here we are getting a very, very important relation which is going to be used everywhere, that the ratio of the thickness H naught by H1, that is always going to be equals to V1 by V naught. So this ratio is always going to be equal. Okay. So guys, you know, whenever the material is entering into the rollers, it is having some velocity of V naught. And when it is getting exit, it is having some velocity of V1. But you know, whatever the changes of velocity happens, they are happening from this to this range. Okay. After that, there is no change happening. So every change is happening in this range only, because this is the range where complete height is getting changed. So guys, I would also like to tell you here that there is a very, very important zone. There is a very, very important zone from where we can make a section. Okay. This section is said to be neutral axis. Okay. Sorry, not neutral axis. This is said to be neutral plane. What is the neutral plane? When you see this neutral plane, initially, whenever we are talking about from this point to this point, in this point or in this region, whenever we are talking about, the velocity of rollers are going to be more than the velocity of material. So in this range, the velocity of roller is going to be more than the velocity of material. So guys, if that is the case, if we are talking about the entering velocity, at this instant, the velocity is going to be V naught only. From this to this, there is no change in height, so no change in velocity. But here height change happens, so velocity change will also happen. So guys, velocity of roller is more than velocity of material in this zone, and at this neutral plane, we are going to have velocity of roller to be equal to the velocity of material. And after this, in this zone, the velocity of material is going to be more than velocity of roller. So my dear, as you know, in the initial zone, in this zone, our material is lagging, so it is said to be lagging zone. Okay. And in the second part, as our material is leading, it is said to be the leading zone. Okay guys. So in both the zones, whenever we are talking about lagging or leading, there is Teju, actually actual formula is only used. Okay, no issues TPM, I will see. So Teju, I would like to tell you that whenever we are talking about the actual formula or theoretical formulas are used whenever we are going with the assumptions that ideal work condition, when we are considering friction is not present. Okay, so they are, if they are not giving you coefficient of friction, you cannot use the actual formula. For that case, you will be using sigma into BL. So that I told you, that is condition of ideal work. So if they are not giving you mu, you can however not use that formula which you are talking about. Without the given data, how you will use that? For such cases, we go for ideal work. Even till date, only 2 times they have asked question from the actual formula. Otherwise, they are asking from the ideal work only. Okay. So moving further, guys. So when we are talking about leading and lagging zone, and if we are talking about this is the neutral plane. At neutral plane, both the velocities are becoming equal. So this is the rolling process, guys. Okay. And if we are talking about the distance from this center, this is said to be arm length. It is denoted by A. So for the neutral plane, the distance is A from the center. Generally, people are thinking that neutral plane is passing through the centers of roller, which is not correct. Okay. Then Teju, share the question with me, then I will tell you for that. Okay. If you find such kind of problems, do share it with me. Then only I can give you the idea what is the problem. Okay. Yes, good morning Ajay. So we are starting guys. So everybody got it guys. So I told you for metal forming and sheet metal operation I will go slowly. For other chapters I will tell you only the formulas. Okay. Because you requested for this chapter because this was not covered in marathon. Okay. So everybody is clear. For metal cutting I will just go through the formulas. Is it clear for everyone? So this is the assumptions we are moving with, and this formula we are going to use many a time. And guys, now I would like to tell you, you can see here the actual reduction is going to take place. So here roller is going to apply some compressive and shear forces onto the material. So if someone asks you what kind of stresses are going to induce in the rolling operation, so the stresses induced in the rolling operations are compressive and shear. Compression and shear are the stresses coming to the material in this rolling process. Okay. So guys, this is said to be the neutral plane we have seen. Now we are moving further guys. So when we are talking about some important factors now, that whenever we are talking about some important material is entering in the roller, if this is the roller, this is the roller, then you know my dear, on the roller there are majorly two types of forces are working. So there are two types of forces that are working on the material. As we have already seen, there is one force coming from the rollers like this, and this is the force coming onto the material. Then definitely material will be showing some resistance for that, because material will try to take away this force, and that force material will be applying onto the rollers. So if you see the roller, on the roller material will be applying the forces like this. Material will be applying the forces like this. So if material is applying the forces onto the roller like this, it means what material try to take? Material is trying to take the separation of the rollers. Just wait guys, just wait. सर ये वीडियो स्टक हो गया है. Now is it fine guys? Okay. Fine guys. Sorry for the disturbance. So let us continue once again. So guys, we were talking about the types of forces. So from this I will be telling you the forces acting. So if you see guys, these are the rollers. Okay. So whenever rollers are applying the forces onto the material, material will also resist that forces, and that force is said to be roll separating force, because by that force material will try to separate the rollers from each other. Okay. So it means some force is coming like this. Okay, there is one force. Second is whenever this material will try to enter in the roller, obviously there should be some force of friction, because I already told you, except the neutral plane, everywhere we have difference in velocity of roller and material. So whenever the velocities are going to be different, what do you mean by that? There should be some kind of slip. Slip means friction will be present. So in the lagging zone, in the leading zone, in the both zones, friction will surely be there. So guys, there are two forces. One is roll separating force, other is friction force, which are going to act on the material. Okay. So there are two forces. One is friction force, other is roll separating force. So these are the two forces which will be acting. So roll separating force, which is the radial force, and friction force, which is also acting on the material. So that friction force will be acting in two directions, because in the leading zone we are going to have material with high velocity. In the lagging zone we are going to have roller with high velocity. So because of that, in both the zones friction will be having different directions. So my dear, whenever we are talking about the materials, how the forces will be acting, let us discuss. So this is the roller, this is the roller. Okay. So you know, material will be trying to enter inside, material will be trying to enter inside. So whenever we are talking about the material, it is entering from here, exiting from here, let us say. Okay, and this is nothing but the center. And you know that if we are going to see, this is said to be the angle of bite. This theta is said to be the angle of bite. This is said to be the angle of bite. Okay, this is said to be the angle of bite. So in this region, you know that some part will be leading, some part would be lagging. But material is entering from where? Material is entering from this point. Okay, this is the entering point. So here if you are talking about roller is applying the force onto the material like this. This is the force applied by roller onto the material, and you know material is going to enter and roller is having high velocity. So when roller is having high velocity, this is the roll separating force. It is having two components. One component is horizontal, other is vertical. This horizontal component do not tries the material to enter inside the roller. So that is why on the material it is acting in this direction, outside. Similarly, whenever we are talking about friction, as roller is having more velocity in the lagging zone, material is having less velocity in the lagging zone. So I feel everyone would be able to get this thing, that in the lagging zone, always friction will try to take the material inside. Why? Because friction have one tendency that both shall move with the same velocity. Because of that, friction will try to make the entry of the material, and friction will be working in this direction. So if friction will be working in this direction, this is said to be mu n. Okay, so it will be having one component in this direction, other component is going to be in this direction. So what do you understand by this? It means there are two horizontal components which are acting on the material, where this component will try to take the material out of the roller and friction will try to make entry of the material. So if we want that we shall not apply any force onto the material for the entry inside the roller. Okay, so for that what we need? For that we need is that this horizontal component of friction should be more than this component, and that is said to be the condition of the self entry. So we always want that this component should be more than this component. So we have seen, if this is the roll separating force, we are saying this force is N. We are showing it with N. So you know that the component in this direction will be N cos theta. This will be N sin theta. So we will be having N sin theta should be less than or equals to mu N cos theta. Because if N will be having the sin component here, mu N will be having the cos component here. So because of that, you will be having the tangent theta should be less than equals to the mu. Okay, and mu, you know that mu is nothing but the tangent beta. So the point is beta should be more than theta. So beta is the friction angle, everybody is aware. Is it clear? Teju, I will tell you, don't worry. Up to this, everybody is clear or not? Please tell me that. This I am telling you the condition for the self entry. Now we are going to derive the forces. Don't worry, we are going to derive everything. Now we need to see what is this length of arc of contact. So now you tell me, shall I go for the derivation or shall I directly tell you the formulas? Great, great, great. So shall we go with the formulas now? Because I have already explained how the rolling process is going on. This was about the rolling process. I feel now shall we go for the formulas? Everybody is ready, because you know this is something which I need to tell you. Okay, great Ajay. Great Ajay. So guys, whenever we are going to find out this length in which the contact is going to happen between roller and material, then the formula for that is coming out to be actually this. L is equals to R delta H. Here my dear, whenever we are talking about R is the radius of the roller and delta H is the difference of the height. As you know, delta H we can write it as H0 minus H1. This can be written as H0 minus H1. It is coming from the property of circle. Everybody is aware of that. Then my dear, if you want to find out the rolling load requirement, this is the ideal work. Whenever there is nothing given about the friction, then you can apply the formula, the load to be sigma naught L into W. Here my dear, it is W is the width. You can also use the formula in this way, like you are writing the W to be sigma naught into B into L. If you are taking width B, this will be the formula. And L is the length of arc of contact, which is given as R delta H. Okay, so you can apply this formula. Then my dear, you already have seen how hot working and cold working are working, that we have already seen. Now my dear, we will see one more thing here, that if L is the R delta H, you can see that this rolling load requirement is depending upon the sigma naught. This rolling load requirement will be depending on the B. This rolling load requirement will be depending on R. This rolling load requirement will be depending on the delta H. So these are the factors on which this rolling load requirement is depending actually. Okay. So my dear, this sigma naught is nothing but the yield strength of the material. You know that if you will be going for hot working, you can reduce this. And if you are going for hot working, that is why rolling load will reduce. When we are talking about width, this is not at all a factor, because if some component is given, we cannot change the width of that. Otherwise, the component, whatever the component is made for, that purpose will not be fulfilled. So that is not in our hand. That will be depending on application. Then next thing what we can do is the radius of rollers. So my dear, from that we get an idea that if we keep the radius of the roller to be smaller, we can reduce the rolling load requirement. So that was a very good idea, that by reducing the roller radius, we can definitely get lesser amount of loads. You may be thinking, sir, what is the benefit of getting lesser rolling load? Dear, if you are applying lesser force, your power consumption will reduce. That is one thing. Second thing is the life of roller will also increase, because the same force has a reaction coming on to the rollers. Next thing is delta H. So my dear, when we are talking about delta H, it is nothing but the draft per pass. Means how much deduction is happening. This is draft per pass. So if you will be reducing this, then there is a problem. Because let us say you need to reach from 60 to 30 mm. Then my dear, I would like to tell you, rolling is a multi-pass operation. If you will be reducing draft per pass, you need to go for more number of passes. Then once again, overall power will be more only, it is not going to be lesser. Overall energy consumption will be the same, okay, or the more. So that is why that is not an important point. So from here, what we understood majorly important thing is that sigma naught is one parameter, R is the other parameter which can be controlled majorly. So guys, in hot working, whenever we are using, yield strength reduced. Second is draft per pass can be reduced, roller radius can be reduced. Out of these two are the important one, and these two are the things which we can go for. Okay, so let us move further, guys. So guys, whenever we are reducing the roller radius, what is going to happen? Initially, we were using very big rollers like this. Then we reduce the size of rollers. No problem. When we reduce the size of roller, our rolling load requirement reduces. Whenever this happens, we enjoyed that. We reduce the roller size further. Then we reduce the roller size further. Then after some time, what happens? Because whatever the force roller is applying, the same is coming onto rollers also. That is fine. So my dear, when material will apply the loads onto the rollers, roller starts deflecting. Then my dear, when rollers start deflecting, what was happening in that time? Like you are having one roller like this. Initially it was like this. Then because of material force, like this is one roller, this is another roller. So you know material will be going inside like this. So material will be applying the force onto this like this. Okay. Material will apply the force onto this like this. And that force will be acting like, as you know, here the roller will also be fixed from this side, fixed from this end. So because of that, it was acting like a simply supported beam. And the load was acting like UDL, whatever the forces are applied by the material. Under this, the roller started deflected. And if the roller will be deflecting like this, my dear, you know that the shape of the component which is coming outside will not be that for which you are looking for. So because of that, deflection of roller happens. So that is why we cannot go beyond one value. Teju, thoda sa samay do, I am coming on to the formula, then I will tell you everything. This is not a doubt session. You are asking like doubt session. Okay. So otherwise I stop this PPT, then I can take that doubt. So just wait. Formulas will be coming. And only for this chapter I am going to explain. For other chapters I am showing you only formulas. So don't worry. I will be closing this session before 2. Don't worry. Okay. So let us move further. So guys, you know this phenomena is said to be what? So because of that load, whenever you are reducing the radius, so because of that rollers are getting deflected, because of that your component is going to be affected. So guys, that is why we cannot go beyond a radius. Now we found out one more way to do that. So when we are using the small roller, we started using the backup rollers. So there are two things. One, we can go for the cambering of rolls. What is cambering of rolls? Like you already have seen, your rollers were deflecting like this. If you are going to give the deflection to the roller in the opposite direction, then my dear, after the provided deflection by the material, roller will become straight. So the one way is cambering of rolls, the second way is providing the backup rollers. So we started providing the backup rollers because these backup rollers were not allowing the rollers to deflect because they were very heavy. But my dear, power was given only to these two rollers. The backup rollers were not given any power. And guys, I will share you this PDF also in which everything is mentioned. So now this is about the types of rolling mill. Then I will tell you the Teju's questions answer. So types of rolling mill, if we have two rollers like this, one is going like this, other is going like this. This is too high. In this too high configuration, there are two things possible. One is reversible roller, other is irreversible. In irreversible, material will be going first by this. Then once again, the second pass will be like this. So guys, as I said, rolling is a multi-pass operation. Rolling is a multi-pass operation. But the point is, why it is multi-pass operation? Let us say I need to go from 60 to 30. Then I say that these rolling mills are going to do that in the 3 passes. Then you may ask, sir, why it is so? Why it is so? Why we need 3 passes? Because my dear, there is a limit on the maximum reduction. There is a limit on the maximum reduction. So like Teju is saying that, sir, what is difference between mu square r? So delta H maximum is derived as mu square r. This is the maximum reduction you can get in 1 pass. This is the maximum you can get in 1 pass. And less than that you can go for, but more than that you cannot go for. So let us say it is coming out to be 20 mm. Then my dear, if someone asks you this is going to be 20 mm, then from 60 to 30, how many passes are required? Then in 1 pass, you can go from 60 to 40, but you cannot go beyond that. For the second pass, you will not go to 20 now. No, because your requirement is 30. So you will go up to 30. So for this pass, H2 minus H1 is 10. But if you see, otherwise the maximum is 20. So mu square r is the maximum possible reduction, whereas H2 minus H1 is the reduction. So guys, H2 minus H1 can have a maximum value of mu square r. That is the difference between them. I feel now, Teju, I answered your one question. Okay. So guys, when we are talking about reversible, in reversible, 1 pass will be going like this and another pass will be going like this. But how it is possible? Because here this roller is fixed and this roller is movable. So what we are going to make it by motion of this, we are going to set this difference, this distance. So guys, whenever 1 pass will be over, then you will be reducing the distance for the second pass. Second pass will be coming from this direction. You will change the direction of rollers. This is 2 high rolling mill. Then we have 3 high rolling mill. For that we are going to have 3 rollers. Here we are going to pass it like this. Okay, this will save our time. And here this roller and this roller. Okay, in between this roller is also there. So this and this will be running in the same sense of rotation. And this in between roller will be participating in both the rolling operations. The distance between these two and these two will be managed accordingly. This is 3 high. Then my dear, when we are talking about 3 high, after that we have 4 high. When we have 4 high, many people are thinking here that in 4 high we will be having 3 passes like that. They are thinking like in the 4 high roller we will be having like this. This is the thinking of majority of students. Like material is coming from here, then material is going here, then material is going here, like that. So guys, this is material, this is not cloth you will be bending in that way. It will break out. So that is why we are not going to do this much. Okay. So in 4 high rolling mill, we are talking about this. 4 is the number of rollers. We are talking about these backup rollers. So these 2 are the working rollers and these 2 are the backup rollers. So now we will be passing only like this only. And we are going to reduce the chances of deflection of rollers by doing that. And that will help us. And guys, in 4 high rolling mill, we are providing power only to the working rollers. They will avoid the deflection. No doubt about that. Because of these rollers, some loss of power will happen. Okay. But it is required to save the roller's life. I feel you got it. Now, my dear, there is an operation known as pack rolling. If you know about aluminium foil, then aluminium foil is made up of pack rolling. So how that pack rolling is going to happen? In that you are going to take two aluminium sheets and you are going to pass them between the rollers. So my dear, whenever these will be passing through the rollers, whenever you will take them out, you will be getting the aluminium foil in such a way, one side will be dull, other side will be one side will be dull and other side will be finishing. So dull side will be that side which is towards the sheet, and second side which is having some kind of shining surface, that is the side which was in rolling with the rollers, which was in relative motion with the rollers. Okay, so that is why we are having two sides with different kind of surface finish in the pack rolling operation. Then guys, we are also having planetary rolling mill. In planetary rolling mill, we are going to apply some small rollers onto the rollers. So when we are applying these very small rollers, they are acting like sun and planet system. So by doing this, what is the benefit? Now material will be facing the rollers like this. So at multiple points rolling will happen. So this can be done for heavy reductions in single pass. Okay, that is said to be planetary rolling mill. Then there is one process, these process I will show you with the figure. Now I am coming up with the formulas. Okay, so guys, as I already told you, this part is said to be lagging zone and this is said to be leading zone. So in the lagging and leading zone, these are the formulas for the pressure. This is the pressure in lagging zone, pressure in leading zone. From these formulas till date, there is no question in the GATE exam, but I cannot guarantee you for that it will not be, it can come. Okay, so when you see the lagging pressure, it is sigma y by n, n minus 1, h naught by hx at n. What is x? So hx is height at a distance of x. At a distance of x. So this is lagging, this is leading. These are the formula for lagging and leading. And at neutral plane, this px of lagging becomes equals to px of leading. Okay guys, so I would also like to tell you, whenever you are writing h naught by h1, it was equals to v1 by v naught. Similarly, my dear, you can write h naught by neutral plane height is equals to vn by v naught. You know, at neutral plane, the velocity of material and velocity of roller are equal. So you can use that also. During the rolling operation, we apply a back tension and front tension also, so that the sheet will remain the straight. Okay, so that is also provided. So guys, do like and share the session so that others can also be benefited. Are you getting it properly? Please tell me that. Yes. Are you getting it properly? Then we are moving further, guys. So guys, moving further, here what is n? N is 2 mu L by delta H, and delta H, you know that it is nothing but draft per pass. Okay, this is draft per pass. Then my dear, we are moving further for the formula of power. Power is given as 2 times torque into omega, and torque is given as average force into arm length. You already know arm length, I have defined it to you. Average pressure is given as, average stress or average pressure is given as, just wait. Okay, this is given as like this. This is average pressure or average stress. This is given as 2 by root 3 sigma y, 1 plus mu L by 4h. Here h is the mean height. Okay, h is the mean height. This is h naught plus h1 by 2. Then average force is average pressure into B into L. So guys, you can directly write the formula for average force like this. Okay, is it clear for everyone? Is it clear for everyone? Is it clear for everyone? This is the formula for average force. Sir, if we use the formula and formula obtaining using slab analysis, different values are getting. TPM, that is in the forging, I feel you are talking about. One is said to be slab analysis, then that is for different kind of component. One is for the rectangular component, other is for the cylindrical component. So based on the component only you will decide the formula. Those derivations are there in the forging operation. Okay, I feel you got it. I feel you got it. So guys, now we are talking about, we have already seen that how we can reduce the roll separating force by hot working, by reducing the radius. Okay, so roll separating force we have already defined. And I already told you, yes Vijay, good morning. Hi Vijay Brand. So I already told you the stresses induced are compression and shear. This also a question from GATE 2001. So GATE 2011. So this was the cambering of roller we have seen. These are some processes of rolling when we are talking about. So guys, this is a process when we are going to make the threads from the rolling operation. What we are doing here is, we are going to have two plates on which threads are always there. I am showing you Teju once again. This is the formula for average pressure. Previous formula was for leading and lagging pressure. They were variable pressures. This is the average of them. This is average pressure. We are using these formulas generally because lagging and leading formulas are very, very lengthy and they are giving us variable pressure. So when you need to find out roll separating force, average roll separating force, we will use these formulas. Is it clear? Teju, you got it? Yes, Teju, you got it? Is it clear? So I am saying that 2 by root 3. Okay, I am writing it separately. 1 plus mu L by 4H. Is it correct now? I feel this is misprint. Is it clear now? Is it clear now? Yes. Yes. Is it clear now? Yes, I didn't see that properly. Actually, you know, I have heavy glasses, so I didn't understood that at that time. Is it fine? Great, guys. Great. So moving further, guys. So I remember this. You can see I have written in front of you. Okay. So you must remember one thing. This is not delta H. This is H0 plus H1 by 2. So guys, now we are going to see some other processes related to the rolling. Okay, by which material rollers are made? By which material rollers are made? Yes. Okay, Teju. By which material rollers are made? By which material rollers are made? Hadfield steel. Hadfield steel is a type of steel which is having manganese more than 12%. So it is also called as manganese steel. Okay. And now we are talking about one process where we are going to have thread rolling. We will be having these two plates, and I am telling you this is a revision session. The same processes we have discussed in number of hours, if you remember. The same metal forming we have covered, I feel 12, 15, 16 hours like that. Here, this is a revision. So here I am having only important points in the slides. It was very difficult to collect the important point in production. These are two plates. They will be having the threads. And this will be the roller blank. So I will be passing it like this. And by doing that, my dear, this plastic deformation will take place and threads will become onto this roller blank. This is how we can make threads using the rolling operation. Okay. So this is how we can make threads using the rolling operation. So this is threads by rolling operation. So guys, then you are going to have some tin sheds like this. So those tin sheds are going to make by this process. Okay. Then my dear, for making the gears, we are going to have one more way to make the gears by rolling process. So this is how we can make use of rolling process in various operation. I feel it is very much clear to you. Then my dear, we are also going to have a process that is said to be, previously we have seen thread rolling. Now I will show you how we can make hollow section using the rolling process. This is the process. In this process, you can see that there is a hollow cylindrical piece. Outside roller is there, inside roller is there. And this is to provide the shape. Okay. So this is also a kind of process where we are going to make the thin hollow sections with the help of the rolling process. Okay. Everybody remember the process name? This is ring rolling. This is said to be the ring rolling. This is said to be the ring rolling. Okay. Yes, this is said to be the ring rolling. Then this is the, you can say here, this sheet is going to bend using the 3 rollers. It is said to be 3-point bending using the rollers. This process is roll bending. This is said to be the roll bending. I feel everybody remember the names now. This is said to be the roll bending. Okay. Yes. And this is said to be the roll piercing, where we are going to make the hollow section like this. Here, these 2 rollers are provided at different angles like this, which are confirming the self entry of this material inside, and you are having some mandrel which is going to provide the hollow section. Okay. So this is how the things are going to happen. So is it clear? Shall we move on to the next process? Everybody is okay. I have shown you all the formulas of rolling. Satisfied with rolling? Teju, accept that point, everything you liked. Shall we move on now? Yes. Great. Moving further, guys, this time the next process is wire drawing. You know, this is a process of making wires from the rod. Here the stresses induced are tensile in nature. And guys, we are going to have a rod like this. And rod is going to enter in this complete wire drawing process. First of all, we are going to either bend the rod or we are going to twist the rod. Because when you are going to bend or twist, any oxide layer if present, that will go away. Now, my dear, the material is going to enter. In this, there is first zone, which is A. It is said to be the lubrication zone. So in this zone, my dear, we are going to provide the lubricant. Okay. So if you want to provide the lubricant, this zone is for that. Lubricant may be solid lubricant. If you will provide the solid lubricant in form of some powders, then my dear, it will create very good surface finish. If you are going to use the liquid lubricants, that may definitely dull the surface also. Okay. So based on whatever the lubricant you are using, you will get some kind of surface finish. Then my dear, there is a second zone. In this second zone, the actual deformation happens. In this zone, we are getting the final diameter actually. Okay. So whatever deformation happens, that happens in this zone only. And guys, whenever this deformation is going to happen, this zone is said to be deformation zone. Now you know that here you are applying the tensile stresses. In the stress strain diagram, when I was teaching you SOM, even in the classes when I taught you metal forming, I repeated all the stress strain diagram at that time. Here I have not repeated because this is revision session. I cannot waste your time into that SOM again. So guys, you know that if you are going to load the material up to this, then you are going to have some elastic recovery. So definitely that elastic recovery will be there whenever unloading will happen. But my dear, you can reduce this elastic recovery if you are going to increase the time for which the load is present. So guys, to do that, to reduce the elastic recovery, here we are providing this. What is that? That is said to be the region which is said to be stability zone, and this is provided so that this is very big, 2 to 3 meters long. This is provided to avoid the elastic recovery. It is said to be die land. And why it is provided? So that whatever the deformation happens, the elastic component gets converted into plastic. For that we are providing the time. Then my dear, as you have provided some kind of lubricants also, and in this region deformation and stability zone, it is having high temperature and pressure. So because of that, drainage of lubricant is very, very important. For that purpose, and if some elastic recovery is present, for that purpose we will provide this opening of dies. So this opening of dies is going to help us in 2 things. One, if any elastic recovery happens, that will happen here. And second thing is drainage of the lubricant. Otherwise, that may harm the surface. So for that purpose, we are providing it. Here, alpha is said to be the semi-die angle, 2 alpha is said to be the die angle. So guys, whenever we are talking about these sections, section wise, it is said to be approach section. Okay. It is said to be approach section. It is said to be relief section. This is approach. This is relief, and previous one is said to be the die land. Okay. and otherwise this is lubrication zone, this is deformation zone. This is how we can divide. I feel everybody got it. I feel everybody got it. Okay. So guys, this is a cold working operation. Whenever we are talking about rolling, whenever we are talking about forging, whenever we are talking about extrusion, if nothing is mentioned, they are hot working. And wire drawing, if nothing is mentioned, it is going to be cold working. Okay, I feel everybody is getting it. Now we are moving further. So guys, now we are talking about the effect of die angle. So guys, whenever we are talking about effect of die angle, as the die angle is getting increased, initially the wire drawing force reduces and becomes minimum and then start increases. Why it reduces? Because as you are going to increase the angle, you know here this is the contact surface, and when you are increasing, this is the contact surface. So my dear, the contact length reduces with the alpha, because of that friction force reduces, and that is the reason initially wire drawing force also reduce. But after some time it gets increased, because whenever you will be having the minimum contact surface, after that reducing it will create the hindrances. So for that purpose, then we need to take care of this also. Okay, then we need to take care of this also. Is it clear for everyone? So we are moving further, guys. Okay. Okay, guys. So if in question die angle is given, Manas, whatever formulas we have derived, we have taken die angle to be alpha, sorry, 2 alpha. So based on the formula you are using, our alpha is the semi die angle. So if they say the die angle is 24 degree, then alpha will be 12 degree. So in the formula, wherever we have alpha, you will put it 12 degree. Okay. So the point is, in our formula, alpha is not die angle, alpha is semi die angle. Okay. Moving further, guys. So now I am coming to the true stress and true strain. I feel everybody aware of the formulas in the SOM. We have derived it. The true stress is given as engineering stress into 1 plus engineering strain. That is already known to you. Then true strain is given as that is ln 1 plus epsilon E. But you know this is going to be plus for tension, minus for compression. So these are the formulas for true stress and true strain. I feel everybody remember that. Okay. So this also we have derived in SOM. Now percentage reduction in area from this 4 to 5 questions are there in the previous years. That is A0 minus AF by A0 into 100. Okay. Then there is drawing stress. We have already seen that is the true stress. Okay. Then my dear, true strain formula. Then drawing load is given as force into final area. I would like to say there is a difference between extrusion and wire drawing. Extrusion and wire drawing have the same formulas, only one difference is there. Force of extrusion is found out using the stress into original area. Here it is stress into final area. Always remember that. Okay. And the stress here is given as as you know, sigma naught ln R. Okay. So this is how we are going to define it here. R is the extrusion ratio, which is original area but a final area. Always it is going to be more than 1. R is said to be extrusion ratio. Then guys, we are coming on to forging. Everybody is clear about this, and I will show you the this is the ideal formulas. Real formula I will be showing you with the extrusion. I feel everybody got it. Okay. So generally questions are coming from ideal only. Moving to the forging operation, I feel everybody know that forging is also a bulk metal forming operation. If nothing is mentioned, forging is hot working operation. Okay. And I have already given you the short notes also, the formula notes. where all the formulas are present. Okay, so you can use them also, but take it carefully because they are also typed right now in this time only. So just see that if some typing errors is there, then definitely you need to take care of that, because I have not got that much time that I go through each and everything there after typing. Okay, I have seen once, but still some small mistake can happen. So guys, when we are talking about forging, it is a bulk metal forming operation. You already know we have rolling, we have wire drawing, we have extrusion. Why we need forging? What was the problem? You say, sir, forging we are going to apply compressive forces. In wire drawing we are going to provide tensile stresses. It is not like that, because even whenever we use extrusion, there we are providing compressive forces. So compressive forces are present in extrusion also. Then what is the difference between extrusion and wire drawing? Sorry, extrusion and forging. Anybody can tell what is the difference between extrusion and forging, when in both we are applying the compressive forces? Anybody? Manas, Ajay, Teju, Sujish, Akshita, Malesh. Anybody? Yes. What is the difference between extrusion and forging? When we already have extrusion, why we need to study forging? In extrusion we get prismatic product. Very good, because in extrusion we can provide only the forces, we can get only the uniform cross section products. In forging we can have non-uniform sections also. The example is connecting rod. Okay, the example is connecting rod. Forging is of many types. The very basic type of forging is smithy. So I always give an example. You have seen the movie Sholay. There is a dialogue, Loha garam hai, maar do thoda. So guys, that dialogue is saying do the forging. Forging means that only. Loha garam hai, maar do thoda means we will heat the metal and we will just use hammer to give the desired shape. That is nothing but the smithy or smith forging or hand forging. Then if you are using dies, then there are open die operation, closed die operation and impression die forging. My dear, this is the improved version of open and closed die only. So let us see how they looks like. Smith forging is similar to hathoda, mardo, loha garam hai. Wahi. Okay, this is simply heat the metal and apply the hammer. In open die forging, what is the case? In open die forging, we will be using the dies for sure. Okay. Then my dear, you will be hammering to give the desired shape. But what is the problem? We are having control in this direction, but there is no control in this direction. So because of the no control in the lateral directions, it is not going to be a very, very efficient process for complicated shapes. Then my dear, other operation is closed die operation. In the closed die operation, we have the proper control in all the direction. There you will be having dies from all the sides. But here the problem is we need to exactly calculate the required material so that which can fulfill the cavity. Otherwise you will not be getting the good product. And if you are not going to calculate the material completely what is required, if you are going to calculate it lesser, then my dear, after the completion of product, you may get the product like this. Some part will remain empty if the material is not proper in the amount. So the problem is the exact calculation. Then we are going to have the next operation is impression die forging. So when we are talking about impression die forging is having this kind of thing. It is having this kind of thing. Here die shape is like this. This is the die. Second die is this. What is this? This is the cavity in which the billet will be kept. Then my dear, this part is said to be gutter. Here we are not going to exactly calculate the material. We are going to provide some extra material. So that extra material will be going into the gutter. Okay. And my dear, it should go only after filling the cavity. That is why we have provided this gap, because material have to cross this friction to go into gutter. So because of that, only excess material will go, and this excess material will be going in the form of flash. So guys, flash is the material how it is going on in the form of flash, and gutter is the place for the extra material. Then we have some operation like edging and fullering. Edging and fullering. So when we are collecting the material at some place, that is said to be edging operation. If we are allowing the material to go out, it is said to be fullering. Then my dear, when we are talking about fullering and drawing out, there are two operations. If you are allowing the material to go symmetrically, then it is said to be drawing out. It is said to be drawing out. But if you are allowing the material to go non-symmetrically, like this, here the material will be going at different pace, here different pace, then this operation is said to be the fullering. So fullering and drawing out are similar operations. Then we are having something called as forgeability. Forgeability, my dear, is a way. This is how the connecting rod is manufactured, that I taught you in detail. Here I will not discuss that. This is a revision going on. We will go only for the important points. Okay. Yes. So when we are talking about the forgeability, you know that, my dear, if it is like weldability, it is like castability, it is like machinability. Ability to go for forging, it is the ability of a material to get forged. So guys, whenever we are talking about forgeability, this is the entire list of material, where this is beryllium, this is tungsten, titanium, nickel, steel, copper, magnesium, aluminium. So in this list, aluminium is having highest forgeability. Once question have been asked in P&I from this table, so that is why if you are appearing for P&I, then it is important. Then my dear, we are having a defect of barreling defect. So guys, whenever we are having the open die operations, whenever you are applying the forces, then my dear, whenever you are applying the forces, what is going to happen? If I show you the top view, then my dear, this is the cross section of the billet. So whenever we are going to see the cross section of the billet, what is going to happen? Whenever you are hammering, initially this entire part is sticking to the die, but slowly what is going to happen? Whenever you are applying the forces, some part is going to go away from the dies. So some region is said to be sticking region, where part is just stick to the die, and my dear, some part which is not stick to the die, that is going to be having some relative motion. So guys, this region is said to be sticking region, this is said to be the sliding region. Okay, that is going to happen. As you will apply the forces, sticking region will shrink, sliding region will increase, and when this process is going to happen, because of the relative motion at the junction of die and the workpiece, because of the presence sticking there, my dear, this part is not going to deviate more, but in between part is getting more deformation. So guys, this cylindrical shape is getting converted into non-cylindrical barrel form. Okay, one more reason for that barreling effect is that dies are hot, workpiece is cold. So because of that, this part is coming in contact, because of that, that part is also becoming hot, and that part is also becoming hot for the dies. But in between part, whenever we are talking about, this hot part will become cold because of dies, and this hot part will remain hot. So here deformation happens more because of lesser yield strength. So that is why barreling effect happens. This is a kind of defect. Is it clear? Yes. So guys, Sonu sir is also present in the comment section to just motivate you. You have seen one thing, whether I am taking the session or Sonu sir or Suraj sir or Chandra sir, we are always present with you. Because we want to motivate you. We are always having a search that how many people are still connected, still studying, so that we get to know how your preparations are going on. And if we find someone who is not doing or coming, then we are asking him, where are you? Then if you are going for self-study, there is no problem, but your study shall go on. Okay, so entire team is always worried about you. That kind of worriness is not present at all the platforms, so you are lucky to have that. So guys, now we are talking about the mean flow stress. You must have seen the formula for mean flow stress to be, what is the formula for that? This is K times epsilon to the power n divided by n plus 1. Is this the formula? Yes, this is the formula for mean flow stress. Okay guys, is it clear for everyone? So guys, here I have covered the things which are coming in GATE. but I have shared you the short notes. I will once again share in the Telegram today the short formula notes, in which you can see the formulas of forging, you can see the formula for extrusion once again. Here I have taken only those things which are coming in GATE, because if you see the previous year's GATE papers, whenever they are asking some other thing, they are giving the formulas as well. Okay, so I will suggest you to go minimum with this much, and those formulas you can see from the sheet that you need to remember only. So I have covered it. Now we are moving to the sheet metal operations. In sheet metal operations, we have divided into two forms. One is sheet metal forming operation, other is sheet metal cutting operation. So my dear, in sheet metal cutting operation, we are going to have blanking, punching and shearing. Punching is also said to be piercing. In sheet metal operation, we have deep drawing and bending. Guys, you may be thinking why sir is shrinking. Otherwise, when sir was teaching welding, sir taught for 2 to 3 hours. Here also I can go like that. But dear, in my mind, only one thing is going on, that on 4th Feb you have exam. So I cannot waste your time. I am only going for the important things, and for remembering the formula, I will share you the sheet. I need to save your time, because I know if I will be going up to 5 PM, you will be sitting here. I want you to go for the revisions more now. This is the time for that. Okay. So let us talk about the blanking and punching first. So when we are talking about blanking and punching, guys, punching is also said to be piercing operation. I have made it the diagram note up to the scale. So you know this is a punch. Obviously cylindrical punch is there. And this material is a disc of this shape. This is a disc of this shape. Okay. So my dear, you are going to create the hole into this like this. So when after punching operation, you will be having two things. When you are going to create the hole, obviously this kind of disc you are going to cut from it. So you will be having this red disc separately. And after cutting of this disc, you will be left with one more product. That is the product. Okay, these are the two products you are getting. If you are working for it, if you are looking for it, the operation name is blanking. Okay, and if you are looking for it, the operation name is punching or piercing. What do you understand from that? What do you understand from that? From that we understood one thing, that in both blanking and punching, setup will be same, operation will be same. Only the difference is in the product. So if we are going to have this as a product, disc is required. Our operation is going to be blanking, and we will be taking care of the size of punch. Punch or size of die? Size of punch or size of die? What do you feel? So guys, if you see the punch, this is the size of punch. This is the diameter of punch. And you can see this is the die. Die will also be having some diameter like this. So guys, this punch will be creating hole inside the sheet. Then some product will be coming out. So this blank will be related to the size of die. And the sheet with hole will be related to the punch. So in punching operation, we will be taking care of punch, and in blanking operation, we will be taking care of dies. Is it clear? So guys, if that is the case, why that kind of things are happening? Because when this punch will be passing from the sheet, then my dear, first of all, it is going to compress it. It will be compressing it up to some extent, and you will be having some penetration. And after getting some penetration, only the bonds will be broken. So initially some plastic deformation is happening. Because of that, the size of blank will be different than the size of punch. One more thing is, because of plastic deformation, breaking of bonds, some heat will also be there. Because of that heat also some expansion will happen. So always die size is going to be more than the punch size. Always remember, the size of die is always more than the size of punch. Even we can say the die size is equals to punch size plus 2 times of radial clearance. So guys, this radial clearance is this much. So when we are talking about this radial clearance, this is always found to be less than 10% of the sheet thickness. It can be given in the form of the sheet thickness. Okay. Then I would also like to tell you that this C1 is the diameter clearance given by 2C, and the optimum value of C is 0.0032 times of T into tau ultimate. So this is the optimum clearance. Okay. normal clearance is given in the form of sheet thickness. This is the optimum clearance. Is it clear? Yes, this is the optimum clearance. Then my dear, this is the product we are going to get in the punching. This is in the blanking. So hole size is equals to the punch size. Blank size is equals to the die size. Always remember that. So guys, if we are going for the blanking operation, then we will be knowing the die size. Die size is known to us. And punch size we will be calculating by reducing the clearance from this. So we will say that punch is provided the clearance, because die size is known to us. Punch we are getting with the help of clearance. So we will say punch is provided with the clearance. Then my dear, if you are going with punching operation, then my dear, punch size will be known to us, and you will be finding out die size to be punch size plus 2 times of clearance. So you will say clearance was given onto the dies. So the size which you are finding with the help of clearance is said to be the provided. That die is provided the clearance in punching. Punch is provided the clearance in blanking. It is just opposite, crisscross. Okay, very good guys, wonderful. So guys, blanking, punching and deep drawing operation, they have same setup. Only the difference is in blanking and punching, we are going to have clearance less than 10%, and we are going to have sheet metal cutting operation. In deep drawing, we are going to have sheet metal forming operation, and in deep drawing guys, we are going to apply the clearance of more than 90% of the sheet thickness. Okay, that is the major difference in the three operations. Then guys, we are going to talk about the forces required in blanking and punching. So forces required in blanking and punching are this. This is tau ultimate into area of shear or shear area. So you can write tau ultimate into pi dt. Tau ultimate into pi dt is the blanking or punching force. That is the one formula. Then my dear, if you are going to have a cut, in the sheet like this, then shear area will be W into T or W or B into T. Let us say B is the width of cutter, and W is the width of sheet. Okay, then my dear, this time the shear force will be tau ultimate into, this time it will be W into T. We are concerned with the sheet thickness, not with the cutter thickness. Okay, this will be the formula in that case. Then guys, I feel something is deep drawing is missing. So for that I will write first of all the formula. The minimum diameter hole required. You know the formula for minimum diameter hole required? There we are going to, you are going to equate the stresses coming in the punch and die. How we are doing it, I am showing it to you. So if you see this setup, you know that this punch will be applying the shear force onto the sheet. So sheet will be also providing the same force onto the punch. So on the punch we will be having one force as busting force. The busting force on the punch will be pi dt into tau ultimate. This is the busting force. And we will be having the resisting force as sigma crushing into pi by 4 d ka square. So when you will be equating these two, you will be getting the minimum diameter hole required. I am deriving the formula here only. So you will be having sigma c into pi by 4 d square is tau ultimate into pi dt. You must understand this tau ultimate is for the sheet material and this sigma is for the punch material. So pi will get cancelled out, dd will get cancelled out. You will be getting d is equals to 4 times of thickness into tau of sheet divided by sigma of punch. This is the minimum diameter of hole you can produce. Everybody got it? From this there are many questions. Okay, 4 times T tau of sheet by sigma of punch. I feel everybody got it. Yes or no? Please tell me that. Please tell me that guys, everybody got it or not? Great. So guys, this we have already seen. Now my dear, whenever we are talking about the deep drawing operation, in deep drawing operation, let us say you are having a sheet like this, and from this you want to create a cup like this. So initially this is having a blank diameter of capital D, and the cup you are making is having a diameter of D and height of H. Then you know we just need to equate the surface areas. We are going to write pi by 4 D square is equals to pi by 4 small d ka square plus pi dh. So you will be having the formula of D to be square root of D square plus 4dh. This is the blank diameter. So if you want to find out blank diameter anytime, you just need to equate the surface area of blank with the surface area of the workpiece you are going to get. This is what you need to do. Okay. Then my dear, sometime you know deep drawing is a multi-pass operation. So guys, if you are going to have this as the disc and you are going to make it in this shape, and for this you are going through a multiple operation. First you have this, then you have this, then finally you have this. So why we have multi-pass operation? Because in one pass we have some limit. More than that we cannot go for it. Otherwise the sheet will break. So guys, in GATE, whenever the questions are coming, they are asking something called as LDR. That is limited draw ratio. Limited draw ratio is defined as D by D1. So D1 is the diameter after first draw. Or you can write it as D1 by D2. D2 is after second draw and so on. Okay, so if LDR is given, it is given generally 1.6 to 2.3. Any value can be given to you. If they say we want to convert 60 mm into 8 mm, and they ask you how many passes we require if we have LDR of 2, then my dear, you will say first of all we will be going from 60 to 60 by 2. This is D by 2. This will give you the D1. Why? Because LDR is D by D1. So D1 is coming out to be 30. Then 30 will be converted into 15. Then from 15 you can go up to 7.5. So you will go up to 8. Because LDR will give you the maximum reduction possible. So guys, yes, Teju, I am coming on to that. This is first reduction, then second reduction and third reduction. So number of passes are 3 here. Sometimes they can give you the percentage also. So in the percentage, they will mention you that in the first draw this much percentage, second draw this much percentage. In ESE they do not give, in GATE they give. So it will be like D minus D1. D minus D1 by, yes, D minus D1 by D into 100. This is the reduction, percentage reduction in first pass. Okay, similarly you will be having D1 minus D2 by D1 into 100. Percentage reduction in second pass. Is it clear? Likewise it can be given to us. Very good. बहुत बढ़िया, बहुत ही बढ़िया. So guys, this is something about blanking, punching. Now we are talking about the bending operation. When we are going about the bending operation, this is a sheet initially and this is of length L, and I want to bend it like this. I want to bend it like this. Then this R is said to be the bending allowance. Okay, this R can be written as R plus KT. Okay, here K is said to be the stretch factor. This is small r. T is the thickness. This distance is A. This distance is B. So we are going to say that bend allowance is given as R plus KT into theta. So you can say the total length is equals to A plus B plus bend allowance. Then you know that we have 3 types of bending operation: U bending, V bending and edge bending. Like if you are going to have a U-shaped die like this, this is the U bending operation. If you are having this V bending operation, if we are having this edge bending operation. So in the U bending operation, surface area is more, so more forces are required. So the ratio of force in U bending to the V bending to the edge bending is 2:1:0.5 or 4:2:1. Okay, U bending is used to make the bowls, V bending is used to fold the sheet, H bending is used to bend the sheet along the edge. V bending is used to fold the sheet. You will be folding it like this. Sir, once work done and force ruined in deep drawing. Okay, don't worry for that. So first of all, this is the force required in the bending operation. This is sigma y LT square into C, and here C is said to be the die opening factor. Die opening factor. Okay, so sigma y is the yield stress of the material, L is the length of sheet, T is the thickness, W is the width of die opening. So guys, here what is width of die opening? If you have this will be the width of die opening. Okay, this is the width of die opening. I feel you got it. Definitely Teju, we will go for it. We will go for it. Actually, that formula is there in the end by mistake. Okay. So in bending defect, I feel you are aware about the bending defect, that is spring back effect. So what is spring back effect? Like, you know, if I will be bending this paper, after bending it, it will come back. When I am going to bend it up to this, it will come back to some amount. So that is said to be the spring back effect. It is nothing but the elastic recovery of bending operation. So when we see this spring back effect, this is directly proportional to yield strength, inversely to thickness, inversely to Young's modulus. You can have one question from there. So be ready for that. It is directly proportional to the radius of bending. Okay, always remember that. Value of K will be given to you, Ajay. Actually, that will depend on the thickness. Okay, the value of K will be depending on the thickness and radius. So it is generally varying from 1/3 to 1/2, but its value is always given to you. Okay, its value is generally given to you. Okay, yes. So moving further, guys, moving further. Now we are coming to the minor sheet metal operations. When we are talking about the minor sheet metal operations, we have perforating. If we want to make multiple small holes, जैसे आपने देखा होगा जो हलवाई होते हैं sweet men, they are using a jali whenever they want to make bundi laddu, then they are going to use that jali, which is having so much small holes into that. That operation is done perforating, and here the shear stresses are induced. Okay, and second operation is notching. Once again, shear stresses are induced. You are removing the material from sideways. Whenever you remove the material, the stress is induced as shear in nature. Then we are having nibbling. In nibbling, we will be having a small tool like this, and we will be running this tool onto a path, and you will be getting the whole of the same size and shape of the path. Then this operation is said to be nibbling operation. Then, my dear, we have lensing operation. In lensing operation, what we are going to do? In lensing operation, what we are going to do? We are going to just cut the material like this, and after cutting, we are not going to remove it. So we are going to have this kind of things. Okay, that kind of things are present in the cooler jali. They are present in the radiators. Okay, so here we are cutting and bend. So because of cutting, shear will come. Because of bending, tension will come. Sir, in punching, clearest empirical relation is there, 0.0032. In that C relate to hardness number. Dear, that C, whenever we are talking about C, that C is the optimum clearance. Okay, and that is into whatever you are saying, 0.0032 T into tau ultimate ka square root. So under the square root, tau ultimate is there. So tau ultimate will be depending on the material property. So yes, it is depending on the property of material. Is it clear? And that C is the optimum clearance. That is said to be optimum clearance. But generally, they are giving the thickness, they are giving the clearance in terms of thickness only. Okay, moving further. So then, my dear, there is a process known as coining. You know that in the coining, we are going to put the material, let us say we are having a die like this. We are having a die like this. You will put the blank here, and after compression, you will get the shapes of the die present onto the coin. That is said to be coining operation. There is a coining operation, there is a embossing operation. In coining, as the material is going to fill in this space, then the thickness of the blank will reduce. But my dear, if you provide the extra material and you don't want any kind of reduction in thickness, then you will be saying the operation to be embossing. And you know, embossing operation is done whenever we are having the projection welding operation. Okay guys, then we are going to have the stretch forming. In the stretch forming, we are going to have two dies which are holding the sheet like this, and punch is going to provide the force, and it will be inducing the tensile stress, and this will get increase in the length like this. Then we have the types of dies, my dear. The first type of die is said to be the simple die. In simple die, either we will be having blanking or punching or deep drawing. Only one type of one operation is possible, that is said to be the simple die operation. Then we are going to have compound die. In compound die, you will be having blanking and punching together. So the same type of two operation happening in one stroke at one time at one location. That is compound die operation. Then we have combinational die operation. In combinational die operation, we are having different types of two operations. One is happening blanking, then plus is going to happen is deep drawing. So two different types of operation in one stroke at one place is said to be combinational die operation. Then we are going to have progressive die operation. When we want to reduce the blanking forces, there are two ways. One is to stagger the punch. In staggering of punch, what we are going to do, we are going to have different length, or you can say different size of feet. Different size of feet means what? On the same arbor, you are going to have two punch, from which one punch is more in length, other punch is less in length. What is the benefit of that? If you want to produce two hole into the sheet, one hole here, one hole here. But my dear, one hole is requiring 500 Newton of force, other is requiring 200 Newton of force. Other is requiring 200 Newton of force. If both operations occur together, 700 Newton will be required. But what do you want? You actually want that I need to apply less force. So we will be changing the length of both. In that case, what will happen? Both the holes will be produced at different time. First, this 500 Newton will be applied here and this hole will produce. Then with the same 500, now here no requirement of force. This will also get cut out. So here on this punch, we will be applying only 500. As the reaction also will be coming maximum of 500. So because of that, we are able to produce both the holes. If you are going to produce them simultaneously, 700 Newton is required. So by this way, we have reduced the forces onto the die. Yes, very good, Teju. So this is said to be staggering of punch. There is one more way, that is by providing the shear. When we are going to provide the shear, then what we are going to do? We are going to do the punch like this. So when you are going to provide the shear onto the punch, this is said to be the shear onto the punch. And guys, if you are going to provide shear onto the die, you are providing one die like this, other die like this. So in that way also, the cutting will happen very easily, because here point the point the cutting will happen. Okay, suddenly all the area will not come in contact of punch from the workpiece. So that is said to be the shear on punch and shear on die. Now we are moving to the powder metallurgy. In the powder metallurgy, we are having the powder preparation, then we have blending, then we have compaction, then we have sintering. So in the powder preparation, first of all, why we need powder metallurgy? We have so much processes. Is there any requirement of powder metallurgy? The answer is yes. It is a very, very past ancient process. And guys, this process is used for many purposes. Like if you want to have some kind of composition, like you want 60% of A, 40% of B. In the material science, you know, in the solid solution strengthening, there is always the limit on the solubility. You cannot have any amount of solute into any amount of solvent, because solubility is limited, okay? And you cannot increase beyond a length, beyond a gap, or beyond a value. But my dear, if you want to have desired composition which is not possible in solid solution, then my dear, in powder metallurgy it is possible. You need to make the powders of the metal in the same ratio, and you need to mix them up. And if you will be mixing them up, my dear, then that way you can get that composition which is given by powder metallurgy. In powder metallurgy, you can add metal and non-metal together, which are not possible otherwise. Yes, Mani, very good. So guys, this is what is going to happen in the powder metallurgy. You are going to have self-lubricating components like ball bearing from this. You are going to have a lot of improvement, like if you want to have gas filters, that is done by powder metallurgy. If you want to provide any kind of filling of pores by the oils, like in self-lubricant lubrication, it is also given by powder metallurgy. Okay. Okay, if you want to have that formula, shear force, then you are going to have, that is what you need to do. Whenever we are going to provide the shear, okay, Mani, whenever you are going to provide the shear onto the punch, then what is going to have, you can reduce the force, but you cannot reduce the work done. For that, you can equate the work done like, at that time, you need to travel the distance of shear, I plus KT. I plus KT. Okay. Then, my dear, it is given as normal force which was provided for a sheet thickness into K. Why KT? Here K is penetration to thickness ratio. Penetration to thickness ratio. Okay. So you can write the shear force as F into KT, I plus KT. This is what you are getting by equating the work done. What is F? F is tau ultimate into pi dt. Okay, Mani, sir, it can be neglected if less than 1 mm na? Yes, you are talking about, I feel, shear. Are you talking about shear, Teju? Okay. So guys, this is something about powder metallurgy. Then when we are talking about the powder metallurgy, how the preparation of pattern takes place. So yes, Teju. So when we are having the preparation of pattern, the first thing is atomization. So guys, you are having molten metal here, and you are going to provide air or gas at very high pressure and velocity, which will help to atomize the particles of metal, and you will be getting the powder particle, because solidification will take place of size 10 microns to 100 microns. Second is by electrolysis also, because here also atom to atom of anode, ion to ion of anode will be going on to the cathode. So you can take them in the powder form. Third is you can go by chemical decomposition, because whenever metal oxides are getting formed, then also by going from the chemical analysis, you can separate the aluminium powder. Okay. So this is one more way. You can use the grinding to make the powders. You can make the bowl mills, where you can going to crush the material in the form of powder. So this is how we can make the powders. After making the powders, we are going to blend them. Whenever this blending is done, you are going to add some kind of lubricants also, which are going to reduce the friction. Okay. So guys, after doing that, you are going to have compaction process. Then, my dear, in compaction, we will be having some dye. We will be putting the powder and giving the desired shape to that. After giving the desired shape, my dear, bonding is required. For that, sintering is done. We are going to keep that powder inside the oven for the bond formation to take place. And finally, you will be getting the products. Then guys, you are going to talk about the strength. Because of the presence of lubricant, that lubricants are getting converted into gases, and they are going to go away at the time of sintering process. Then, my dear, there is something called as bulk density or apparent density. So my dear, as you know, in the powder metallurgy component, when the powders are present, there is some void space in the powder. Because of that, density of powder metallurgy component is quite lesser than the component produced by the casting. So that is why the density of powder metallurgy component is said to be bulk density or apparent density. And part density or true density is the density of the component if it is made by the casting process. So guys, the ratio of part density to the bulk density is always more than 1, and that is said to be the compressibility. Obviously, the density is more for the solid component than that of the powder metallurgy component. Then my dear, we are going to have something called as, this is compressibility factor. We have already defined it is always more than 1. Then my dear, sometime to increase this density, we are going for the repressing operation. Here what we do, after compaction, we are not going to sinter it completely. We will go for low temperature sintering. Once again, we compress it, repress it so that the density increases. Then we go for the sintering process. Okay, that is said to be repressing. If you want to fill the pores of the component with the help of lubricating oil, it is said to be oil impregnation. So you are going to add the oil inside the pores. What we are going to do, in the oil container, you are going to put the ball bearing. The pores will be filled with the oil. So the component will become self-lubricating, and that is done by powder metallurgy. The process is oil impregnation. If you want to fill the pores of the component with the help of some other material, like that is said to be infiltration. Like you have a metal which is having high melting point temperature, that is already component formed, and we have some other metal having low melting point temperature, like we have lead or tin. Okay, lead, tin have low melting point temperature. Even for lead and tin, recrystallization temperature is less than room temperature. So even at room temperature, lead and tin are subjected to the hot working operation. Okay, and when we go for the hot working operation of steel, because of iron shows different behavior. So during a range of 150 degree to 300 degrees Celsius, and there is one more range around 600 to 700. For those two ranges, even you are working at higher temperature, but for that, my dear, the yield strength reduces with the temperature for the steel. So we never go for hot working operation of steel in that range. Okay. Then my dear, lead and tin, whenever we are talking about, they are low melting point temperature, and aluminium cast iron is high melting point temperature. If you have those components at 300, 400, they will be in the solid form. You will put them in this oil, in this metal. Then pores of that material or component made up of powder metallurgy will be filled with this molten lead or tin. This is how the things are going to happen. Okay. And guys, what are the applications? Self-lubrication, gas filters. Okay. Then cutting tools which are made up of carbide, ceramics, and tip of them, and tungsten filaments, they are made up of powder metallurgy. Is it clear? Now I will show you some things which have been missed up. Okay, I already told you working temperature more than the recrystallization is hot, less than is cold. 0.3 TM is cold working, 0.3 to 5 is hot working. Okay, that we have already seen. And I already told you for lead and tin. For lead and tin, melting point temperature is 330. Okay, so recrystallization temperature is 30. So that is why for lead and tin, we are going to have always hot working operation. And when we are talking about tungsten, it is having very high melting point temperature and recrystallization of 1300. So guys, these things are sometimes of use. Then I told you, whenever we are going for metal forming operations, they are going to improve the property in one particular direction. Like in rolling, if you are going for rolling operation, you are going to apply the forces in such a way that the length of the component is increasing. So because of that, in this direction, properties will change. Why it will change? Because whenever we are working in the plastic deformation zone, then you know that in this region of strain hardening, the atomic structure changes, crystal structure changes. So because of those much changes, the properties are also changes. That is why we are going to say, if you want a material which is isotropic, you want to make it orthotropic, then by metal forming operation you can do it. So that is why cold working of steel can make the steel as orthotropic. So if you want to make isotropic material to anisotropic or orthotropic, the process done is nothing but the metal forming operations. Okay. Then guys, one more thing was missed here. That is the range. That is the range of temperature for steel. For steel, we are never going to do hot working in this range, because in this range, what is going to happen? The difference, that is previously with increase of temperature, yield strength was decreasing. But for this range, yield strength increases with temperature. So that is why we never do hard working in this range. Okay. So guys, I feel you got it. So we have done this all, and all these things are done already for you. These formulas we have derived. There is a formula for angle of bite. I said some formulas were left. Tangent theta is delta h by r, and from here only we get to know delta h maximum. That is the maximum possible draft is mu square r. So guys, sorry for 2-3 formulas which are skipped. I have kept it here. So this also we have derived already. And if you want to find out normally delta h, so Teju, now your complete answer is coming. Delta h is coming out to be d into 1 minus cos theta. This is the draft, which is h2 minus, h naught minus h1. And the maximum value of it is mu square r. So for formula wise also you need to take care of that. If they are asking you only draft, you will apply this. If they are asking you maximum draft, you will apply this. If they are asking minimum number of passes, this will give you minimum number of passes. This will give you number of passes. Take care of that also. Okay. Yes, very good. So guys, then this is the velocity profile. This is material velocity before lagging, after leading. At this point it becomes equals to roller velocity. This is the neutral plane. Okay, that we have already seen, and these were the formulas we already seen. That is also have been seen. This formula is also seen. Here you can see it is correctly written. So that was some misprint was there. Okay, now it is fine. So that is okay. Yes, that we have seen roll separating force. We have seen all these things. Extrusion was also not discussed. Let us see that. Okay. So you might be saying, sir, why it is like that? Dear, actually, when I was making the PPTs, I was having 1 to 2 PPTs missing. So that is why I tried to add all of them so that nothing should be left out. Okay. And you know, nowadays schedule was going on very hectic. Tonight, yesterday also we have session. So I have made it like this. Nothing should be left. Okay. So some ups and downs may be there, but I feel it will not affect you. So when we are talking about the extrusion, extrusion is a process which is also bulk metal forming, and it is also done in hot if nothing is mentioned. Here 3D compressive forces are applied. If you see every day you are doing the extrusion process in the morning in the washroom, whenever you are going to do the toothpaste. So whenever you are going to apply the forces onto the toothpaste to take the paste out, which is a semi-solid. So it is coming in the uniform cross section because of the opening of the paste. That process is said to be extrusion only. Okay. So guys, first of all, you will be getting the prismatic product. This kind of container you will be having. In this container, my dear, we are going to put some billet of material. And that billet of material is getting compressed with the help of ram. Then, my dear, you will be getting a prismatic shape of uniform cross section product outside from this. Okay. So extrusion, whenever we are going to see, it is of 2 types majorly. One is direct or forward extrusion. Second is indirect or backward. In the forward extrusion, ram and output workpiece material is going in the same direction. So in this, what is going to happen when we make the curve for the load versus the movement, then initially, my dear, we are going to have increase in load. Why load is getting increased? You are going to have the billet in this shape. So whenever ram is going to apply the force onto this, it will be taking the shape of container like this. So because of that, initially pressure increases to fill the container. After that, my dear, as you know, when it is completely filled, as it will start going out, if ram will reach to this position, this much friction length is getting reduced. Because of that, the load is start reducing. But after one time when billet is over, then it is once again increasing to show new billet is required. This is the force for, sir, in rolling force formula, it in 4th or 2H. Sabha, I feel many times we have discussed this. You know that this H is H mean. I have also given you this in the formula memory sheet. There it is written correctly only. Okay, it is 4 only. So now we are talking about indirect or backward extrusion. In indirect or backward extrusion, my dear, the things are different. Here what is going to happen? We are going to have ram travel in this direction, output will be coming in opposite direction. So in backward extrusion, the friction length is limited to this only. Okay, to this only, because material is coming from this, like this. So the material which is present in this zone will not be having any relative motion. So because of that, here the friction curve or load curve will be coming like this. It will be remaining constant until the entire billet will go out. Then suddenly the force will start increasing. So this is the indirect or backward extrusion. But here the problem is with the design of, you can say, ram, that design of container and ram, and you can say dies is very difficult, because when the material is coming out, until it is inside this ram, the control is not there from our side. Because of that, it is very difficult to have long size products. So small and medium size products are done by this. Otherwise, we do not follow the indirect or backward extrusion. Third one is hydrostatic extrusion. It is an improved version of forward or direct extrusion. If we need to extrude the materials which are semi-brittle, then my dear, if they will be having direct contact with the metal, the fracture will happen to their surfaces. So to avoid that, we are making them in contact with the liquid with some lubricant. So guys, by doing that, you will be getting now the extruded product from this, and here fluid is applying the pressure onto this. So there is no metal to metal direct contact, my dear. And because of that, because there is no metal to metal direct contact, we will be having lesser friction. And as the material is brittle, but still we are able to extrude them. So it is said to be pressure induced ductility. It is a ductility coming because of pressure, my dear. Okay, moving further. So guys, for hot extrusion, the formula is KLNR, as I already told you. Here R is the extrusion ratio, which is given as original area but a final area. R is always more than 1. In cold extrusion, formula is given as sigma naught into A plus B ln R. Here A and B are the Johnson constant. They will be given to you. Extrusion ratio I already defined. Here force is given as, extrusion force is given as sigma D into initial area. And in wire drawing, force is given as final area. That is the major difference. And guys, when we are talking about impact and cold extrusion, in impact and cold extrusion, we are going to make the collapsible tubes, and whenever we are using it in the cold condition, otherwise extrusion is hot, and this is we are going to get with the cold extrusion. So I feel with this we have completed the metal forming and sheet metal operation, guys. Now welding, I have already taken a marathon sessions. So for welding and casting, already marathon session is taken by me. For metal cutting also marathon is taken already by Ravindra Tube sir. So that also you can see from those sessions. So that is why for those sessions which we have already covered in the marathons, I will be going through only with the formula, because this is the formula revision session. Okay. So for that I will directly tell you the formulas, nothing more than that. So for welding, my dear, first of all, the first formula is nothing but the percentage dilution. Everybody remember the percentage dilution formula? It is area of penetration but a area of penetration plus area of reinforcement into 100. This is the percentage dilution formula. For metrology also we will have detailed discussion. Okay. Then my dear, we will be having the next formula for duty cycle. For duty cycle, we have I square into D is equals to constant. So I will be writing the formula, and this PDFs will contain all the theory. So if you want to learn the theory, everything is present in this. And if you want to see the session, welding session is present. I will share the link in the Telegram channel if you want. Complete welding, complete casting have been taken by me. Metal cutting plus machine tool operation are being taken by Ravindra sir. All are present in the playlist. Okay. So guys, now we are talking about the duty cycle we have seen. Then there is the equation of transformer. V is equals to OCV minus OCV divided by short circuit current into I. I always write it like V is equals to V0 minus V0 by IS into I. Okay. And if someone asks you the optimum voltage is given by V0 by 2. And optimum current is given as short circuit current by 2. This type of formula they are asking many times, and everybody is aware that power is given as V into I. What are other formulas involved in the welding operations? One more formula is related to the heat and efficiencies. So you know that first efficiency is defined as the heat transfer efficiency. That is given as heat supply but a heat generated. Then we have the melting efficiency or thermal efficiency, which is heat required but a heat supplied. Then we have overall efficiency, which is heat transfer efficiency into melting efficiency, and that is given as heat supplied but a heat generated into heat required but a heat supplied. So it is heat required but a heat generated. Okay, so these are the efficiencies and various heat transfer in the welding operation. Okay, I feel all other things we have already discussed. There is no other formula, okay, as far as formulas are concerned. Is it clear for everyone? Bolo bhai, everybody remember that there is no other formula in the welding. Okay, so now we are coming to the machining part. Machining part, sir, in centrifugal casting we have to use, dear, you will be taking the maximum radius for that. Okay, I already told you that in the books it is given as mean radius, but last year when the question came in the gate examination, they have considered the outer one to find out the maximum one. Okay, I feel you have seen all of them. Outer you will be considering. So when we are talking about the machining operation, okay, here also only formulas will be discussed because it is done in complete detail. For 8 hours sir have taken that. Sir, normal gas welding mixtures, that is not formula, dear. That is not formula. If still you have any doubt, I didn't get what is you trying to say. So guys, we have ESE tool signature like this, where alpha is the rake angle. Alpha is the rake angle. This is the relief angle. Then C is the cutting edge angle. And then ORS system is I is inclination angle, alpha is normal rake angle, gamma is relief angle, lambda is approach angle, R is radius. Okay, are you talking about gas welding? Mani, are you talking about gas welding? For gas welding, if you are having O2 by C2H2 ratio is equals to 1, it is neutral flame. If you have O2 by C2H2 ratio 1.15 to 1.6, it is for oxidizing flame. If it is around 0.7 to 0.8, it is carburizing flame. Generally it is less than 1, generally it is more than 1. Okay, fine. Great, great, great. So guys, now this is the relation when you want to convert ESE to ORS. These are the formulas to convert ESE to ORS. Here I is inclination, alpha is normal rake angle. So left hand side is for ORS. And then alpha B. They are the ESE system. Lambda is the approach angle. Then from ORS to ESE is this one. And you already know if the second last digit is more than 30 degree, then it is ORS. Less than 30 degrees, sorry, more than 30 degrees, this is ESE. Is it clear? It is going to be more than 60 degree. It is ORS. Everybody clear about this? Please tell me that, guys. Yes or no? Okay. As you know, I would like to suggest you one thing. As 4th February you have the exam. I will suggest you for 2nd and 3rd February, you should dedicate only for the revision purpose. Okay. So finally I am asking, if you want any other thing from my side, anything, please message me in the comment or telegram. For any subject, anything you want from my side, please message. Either I will try to provide you on the app or on the YouTube by tomorrow or at the max day after tomorrow. 2 and 3 February should be reserved for you guys. On that day, I will not suggest you to go for anything else other than revision. Only and only you with your notes. Even on that day, don't try to come or go to anything else. Only your notes and you. Nothing else should be there. So I am saying you once again, I am ready to help you out anyway. Okay? Yes. Is it clear, guys? Everybody got it? Why I am saying this? Yesterday also we said the same thing to you guys. Fine. Wonderful. Yes. And if I skip today also in this session, if you find anything is missed up, any formula, or you have any confusion, I will share it with you on Telegram or WhatsApp. So don't worry. Moving further, guys. Now, guys, these were the formulas. Now we are coming to some other formulas like chip thickness ratio. Chip thickness ratio is given by T1 by T2. You know that it is always less than 1 because chip thickness is always more than uncut chip thickness. And that something is chip reduction coefficient, which is denoted by zeta is 1 by R, that is T2 by T1 is always more than 1. And you can find out this chip thickness ratio by this relation. This is T by TC. TC is chip thickness. LC by L. LC is the length of chip. VC by V. VC is the chip velocity. Phi is the shear angle. Alpha is the back rake angle. You can write it as VF by V, because we show the chip velocity by VF, flow velocity. Then, my dear, we have the relation for shear angle as tangent phi to be R cos alpha by 1 minus R sin alpha. Then shear strain is tangent phi minus alpha plus cot phi. So if someone asks you the minimum value of shear strain, that is 2 if alpha is 0. Okay, otherwise you need to calculate it. Then, my dear, we are having a relation for velocity triangles. For velocity triangle, I am writing it separately, V by cos phi minus alpha. This is the cutting velocity. Then V chip flow velocity is VF. You can make it VF sin phi. Then shear velocity is VS cos alpha. So this is the velocity triangle relation. So here VC should be VF, chip flow velocity, and V is the cutting velocity. Okay, always remember this. So next we are talking about the shear plane area. It is given as BT1 by sin phi. Anybody remember the shear strain rate? What is 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 shear strain rate? Anybody, guys? What is shear strain rate? This is shear velocity by TS. What is TS? What is TS? Is it 25 microns thickness of shear plane? Am I correct? Yes. Moving further, guys, this is the merchant force circle. You know that in this merchant force circle, this is Fs, shear force. This is nothing but the normal force. And this is the resultant. And this is cutting force, thrust force, resultant. Friction force, normal force, resultant. So, guys, you can take the 3 triangles and you can write everything in the form of resultant also. Like if this is the resultant, okay, this angle is beta. So you can write N is equals to, N is R cos beta, N is R cos beta, yes. So N can be written as R cos beta, F can be written as R sin beta. So in that way we can make the relation. We can make the relation like N by R is cos beta, F by R is sin beta. So likewise we can make the relation for every triangle. So very good, thickness of shear zone. So guys, this angle is phi, you know that pressure angle, this is beta minus alpha, this is alpha. This is beta. Guys, if I want, I can go into detail of that also. But as I said, all these things we have covered in the marathon. So there is no use of this. This will be a wastage of time otherwise. So this is how we can find out the relation. Okay. This is for F by sine beta, N by cos beta, Fs by cos phi plus beta minus alpha. Tangent beta will be written as F upon N. F is friction force, N is normal force. These are the four relations you must remember for the numerical. If you remember the notes provided by me to you guys on my Telegram and WhatsApp, I have given you a shortcut to remember this in the form of matrix. You can follow that as well. That will be totally your choice. So guys, do like and share the session. Then there are some special cases also when you will be considering alpha to be 0, you will be getting Ft will be F, Fc will be N, and the diagram will become a rectangle. Okay. This is the Merchant first angle relation for the optimum minimum power requirement, that is given by 2 phi plus beta minus alpha is equals to 90. Then it was modified as 2 phi plus beta minus alpha into quote inverse K, which is said to be machining constant. Then Lee and Schaeffer have done the experiments and found phi plus beta minus alpha is 45. Then Stablers have given phi plus beta minus alpha by 2 is 45. Question can come from these three. From Stabler till now there is no question. Okay. Then we have the power requirement is Fc into V. And you know, whatever you are providing in the cutting format Fc into V, you are going to use it in the shear plane and also in the friction. So you are going to use all the energy which is coming. Sometimes I miss to see which velocity asking. Sir, he mentioning velocity of chip related to tool or workpiece. Dear, just look at me. Just look at me. So when he is saying velocity of chip normally, then he is asking about VF, that is with respect to tool. But if he mention velocity of chip with respect to workpiece, then he is asking about the shear velocity. So always see the sentence. If nothing is mentioned, you will take it VF. But if he is saying with respect to workpiece, then it is shear velocity. Okay, Teju? Sir, in machining operation, I only know these four relations and some related formulas like that, sine rule, chip thickness ratio formula. Sir, will it affect more? Dear, generally questions are coming from that only. Generally questions are coming from that only, but you must have a command on the merchant circle. So if they give any condition, you can at least adjust according to the given conditions. That is what is required. And you need to remember the conversion of oblique to orthogonal. That also I have given you in the PDF, where I have in one sheet only mentioned all the conversions, if you remember. And after that I went for derivation also. And if still you want to see on YouTube also, in the marathon that part is covered. Even in your classes also, you will see the entire metal cutting and machining part when you will do. All these things are covered, but this is the major part from which question is coming. Generally one question is coming from merchant circle. Okay, is it clear? Then my dear, you know Fc into V is the power. Total power is used in two things. One is breaking the bond along the shear plane, and second, they are used to have a fight with the friction. So that is why the total power is equals to Fs into Vs plus F into Vc. F is the friction force here. Okay. So material removal rate is given as FdV. Okay. F is feed, D is depth of cut, V is velocity. Then specific cutting energy is given as work done by MRR. This is MRR, not MMR. Okay. Moving further. So guys, with the specific energy, the relation is US is equals to U naught into T to the power 0.4. T is uncut chip thickness. And specific cutting pressure is Fc into Vc by T1 B Vc. And you can cut this and you can get Fc by A naught also. Moving further, tool life, which is very, very important. For tool life, Taylor tool life equation is very, very important, as you know, which is given by Vt to the power N is equals to constant. And here, you know, C can also be defined as velocity for a tool life of 1 minute. Velocity for a tool life of 1 minute is nothing but this. Sir, in machining operations, okay, I feel that already have been covered. Then my dear, you know that after all it was found that velocity is a function of, tool life is a function of velocity, feed and depth of cut, and relation was modified. What was the modified relation? V, t to the power n, f to the power x, d to the power y is equals to constant. This is modified Taylor tool life equation. Machinability, you know that if it is nothing but ease towards machining. So for finding out machinability, we can see the cutting force requirement. If it is getting increased, if it is getting reduced, based on that we can see machinability. If it is less, machinability is good. So my dear, machinability index is one of the criteria to find out this. It is defined as the velocity of a cutting velocity for a tool life of 1 minute for specimen by standard specimen into 100. Standard specimen is taken as free cutting steel, which is having excellent machinability. So guys, then we have economics of machining. You know, in economics we are having a number of costs included, that is tooling cost, tool changing cost, overall machining cost, actual cutting cost, handling cost, and for that we have 3 criteria also. One is one is maximum production criteria. One is maximum production criteria. Second is minimum cost criteria. And if you see these 2 criteria, I have mentioned the formula for the tool life. So the optimum tool life by minimum cost criteria is 1 minus n by n Tc plus Ct by Cm. Ct is the tooling cost, Cm is the machining cost per minute, Tc is the tool changing time. For maximum production rate criteria, this is the optimum 1 minus n by n into Tc. In the classes we have seen the derivation of that also. Okay, then my dear, if you see the 3 criteria, one is minimum cost, other is maximum profit, other is maximum production. Then from these 3, this is the relation. And if you see 2 criteria, minimum cost will be having this curve, maximum production will be having this curve. We are operating always in this range. Okay, so always the velocity is maximum for maximum production and it is minimum for optimum or minimum cost. So we will be having this range as operating range. तो हम लोग इस रेंज में ऑपरेट करते हैं जो कि ऑप्टिमम वेलोसिटी और मैक्सिमम वेलोसिटी के बीच में होती है. So one is given by minimum cost, other is given by maximum velocity. I feel everybody got it. Then my dear, machining time is given as B by Fn. Uncut chip thickness is T F sin lambda. This is whenever we are going for width of chip is given D by sin lambda. Then material removal rate is F N L D. This is given. This is for shaper and planer. Okay. In shaper and planer also we have went through a lot of derivations, and this also is already covered in the marathon part. So I am showing you the formulas only. Then turning and facing operation. Time per cut is L by Fn. And here L is D by 2 AP OR. AP is approach, OR is overrun or over travel. Okay. Then we are going to have forces. Whenever we are going for orthogonal analysis, we are going to have the forces. There is one force is said to be feed force, which is in the radial direction. So based on that, we can also find out. And this is the case of turning operation. Whenever we are going for turning, then my dear, there is something called as taper turning. In taper turning, we are going to make a component which is taper, which is having different diameter at both the ends. Okay. So here if you see, this diameter is bigger one, this is smaller one, and this taper angle is 2 alpha. So for such cases, we can define tangent theta as D1 minus D2 by 2L. So D1 is the bigger diameter, D2 is the smaller diameter. So my dear, this is D1 minus D2 by 2L. Actually, the mean diameter is D1 minus D2 by 2L. It is equals to tangent theta. Why we are taking 2? If you see that, you know that this is the triangle where this angle theta is made. So this distance is nothing but D1 minus D2 by 2. Okay, and the same is with this distance. This is also d1 minus d2 by 2. So you can define the theta from that. Sir, if width of the cutting to producing slot, it is horizontal milling, na. I didn't get your question, Teju, but I feel for these kind of things we have covered in the milling. Okay. If you find any difficulty, share the question with me. That will be better. Okay. With the question, I can help you better. So you know that if we are talking about angle is small, for small angle, alpha will be equals to tangent alpha, will be equals to sine alpha. So we can also write sine alpha or tangent alpha is d minus d by 2l, and from that we can also write it as the L into d minus d by 2l. So that is nothing but the stroke length. Okay. So I feel these things we have already covered. Is it clear, guys? So for the machining operation, as I said, we have already covered in the marathon all those things. If you find any difficulty, share the question directly to me. So guys, now we are coming to the metrology and inspection part. Now please tell me, do you want me to explain limits, fits, tolerance, all the things, or because there is also no formula like thing. Here I can go for the limits, fits and tolerance. So I feel everybody will be clear of this fact that from metrology, major questions are coming from limits, fits and tolerance. Sir, if offset of tool is providing in taper operation. Dear, for that also, okay, go and no go gauge calculation you need. Okay, TPM. So TPM, if offset is provided, that is said to be, I feel we have covered it. One is tail stroke method, other is going to be this, you are saying for offset method. So for all these things, formula we have derived. If you still have problem TPM, just as I said, just share with the question with me. Then I will be able to help you properly. Because I feel all these things are already derived in the marathon sessions for you. So if you want the solution of such problem, then share the question with me. I will give you the solution. Because here I don't have any statement for the questions. Is it clear, TPM? Because this session was related to formula revision, I just intentionally added the revision of metal forming because it was not happened to you. Otherwise, in this session, it was not supposed to have question. So there is no question in the PPT. Okay. Work tolerance and wear tolerance, how to take. Okay, I'm telling you that. So sorry if you were expecting the question TPM. Sorry for that. Tell me that. I will be definitely including either in tomorrow's session, or let's do one thing. You share the question with me. I will share the solution with you. If you still not happy with the solution, we will include that in the tomorrow's machine design session, or I will be connecting with you on the Zoom session like that. Okay, I will help you in that way, if that is the case. So now we are talking about the metrology and inspection. Whenever we are talking about, here we are talking about inspection majorly. Like, something is said to be measurement, something is said to be inspection. Measurement means like if I am measuring the dimension of this to be like this, and I am saying this is 20.1 mm. This is measurement. What is inspection then? In inspection, we just try to see whether the size of this component is in desired range or not. That is said to be inspection. Okay. So guys, actually, whenever we are talking about machining, duplication of anything is impossible. We cannot duplicate the products. So as we cannot duplicate the products, so my dear, always whenever we are thinking that we are making a component of 49.5 mm, in reality, we are getting the component from 49.4 to 49.6 mm. So that kind of difference will be found out. Means you will be getting different sizes for all the component, and size will vary from this to this. So my dear, this kind of difference will be depending on the capability of machine. that will be depending on the machine to machine. Means if you are going for advanced machining, this will be getting reduced. So my dear, if someone want to have this size, he has to mention in which range he will be accepting. For example, I will give you, let us say I want 49.5 and I said that I will be expecting the part from 49.495 to 49.505. I am saying this is going to be my accepting range. Then this accepting range is said to be the tolerance. This is desired tolerance. And this is machine capacity or machine capability. This is what machine can produce and this is what customer is accepting. So there is a difference between machine capability and what is called as desired tolerance. So this thing is said to be desired tolerance. Okay guys, so we are not getting the product in any size and shapes. Generally whatever the size you will be getting, it will be following a normal distribution curve. Okay, so it will be following a normal distribution curve. So you will be getting sizes within some of the range. Then my dear, obviously you know what is accuracy and precision. So my dear, if this is your target size, this is what you are looking for. This is what you are looking for. And this is what major parts you are getting off. So if that gap is very, very less, it means it is nearly accurate. But the ranges of size is far away. That is having very long range. Then you are calling it as not precise. So precision is repeatability and accuracy means near to the exact value. So if you are going to have, if you have a target of 75 marks in GATE and you give the GATE this year, you are getting the 50 marks. You are very far away from the target. Next year, once again, you get 50 marks. Next year, once again, you get 50 marks. So you are precise but not accurate. But if you want 75 marks, you get 74 this year. You are accurate. If, my dear, you are expecting 75, you are giving 5 times GATE. Every time you get 74, 72, 76 like that. You are accurate as well as precise. Okay. But if one time you get 50, other time you get 30, next time you get 80, you are neither accurate nor precise. So guys, this spread is telling us precision. If that spread is less, it is precise. If that spread is more, it is non-precise. Accuracy will be telling on this gap. So if you see here, the gap is less, so accurate. This is also less, so precise. If you see this, here accuracy is not there. Accuracy is not there. But this is very small spread, so precision is there. Here neither accuracy is there nor precision is there. Is it clear for everyone? So guys, now we are directly moving on to limits, fits and tolerances. So let us say we are going to talk about the assembly. I am writing 25 H7 F8. Then you know this 25 is nothing but the mean size. So I will be telling you one question, from that you will be getting everything. When you say H type of hole, I am showing it with the capital H. Holes are shown by the capital letter, shaft are shown by the small letters. So this H type of hole is something with 0 fundamental deviation. So this is H type of hole. And this difference is giving us IT7 is the tolerance grade. Then F8, you know that H type of hole is coming on this line. So H type of shaft is coming onto this line. So F type of shaft will be present somewhere here. So this is going to be the fundamental deviation of F type of shaft. Okay. And guys, this is the upper limit of hole. This is the lower limit of hole. This is upper limit of shaft. This is lower limit of shaft. Okay. So this is fundamental deviation. This is IT8, the tolerance grade. So limits, lower limit is that which is near to the 0 line or nominal size. Upper limit is which is having the upper size. Lower limit is which is having the smaller size. Fundamental deviation is the deviation of the size which is near to the mean line. Okay, is it clear? Is it clear? Yes. So guys, first of all, we are talking about limits, fits and tolerances. This is tolerance. This is limits. Okay, then my dear, what is fit? Like if you have this bottle, you can consider it as shaft. You can say this is the dhakkan, which can be considered as a hole. So whenever you are going to make this assembly, what is the relation between this assembly of shaft and hole? That is said to be about the fits. So guys, how we will define the fits? I am telling you that. From this figure, they are also showing you some kind of deviations. So the deviation of this size is upper deviation, this is lower deviation. So here this is upper deviation, this is lower deviation. So upper deviation is always defined with the upper limit. Lower deviation is always defined with the lower limit. So for shaft, this is the lower limit, so this is lower deviation. This is the upper limit, so this is upper deviation. So deviation, lower deviation can be more than upper deviation for sure. Okay. Then my dear, we are talking about this chart, which is telling us the fundamental deviation. One by one we will see everything. Money, don't worry. So here we are going to have A type of hole, B type of hole, up to here H type of hole. We are going till Z type of hole. Then we have A type of shaft, B type of shaft, H type of shaft, like that. So guys, whenever we are talking about fundamental deviation, there are 25 types of fundamental deviation. But whenever I say 25, generally student feels there are 26 letter A to Z. So they feel for H fundamental deviation is 0. And otherwise there are 25 letters. So there are 25 fundamental deviation based on 25 letters. So this logic is incorrect, because there are some letters which are absent also, and there are some letters for which we have subscript also, like ZA, ZB and ZC. So guys, this is the fundamental deviation. If it is coming below the line, it is going to be negative. So whenever you will be using the fundamental deviation for A type of shaft, it will be negative. For A type of hole, it will be positive. So for that, formula is generally given to us for the fundamental deviation. You need not to remember it. It will be given in the question. Okay, this will be given in the question. Okay, Mani. So this is given in the question. Okay. So if we are using H type of hole, it is said to be hole basis system. If you are using H type of shaft, it is said to be shaft basis system. Then guys, whenever we are talking about the fits, the first type of fit is said to be the clearance fit. If you are going to have the lower size of hole to be more than the maximum size of shaft, you will always be having some gap between them, which is said to be clearance fit. So my dear, whenever we are saying clearance fit, you know that if we are going to close this bottle with this tip, if we are easily able to do that, that means the clearance between them is the kind of clearance fit. It means this is the shaft, this is the hole. If you have some gap, it is going to be clearance fit. Okay. So guys, this is the minimum clearance and this will be the maximum clearance. So then second type of fit is we are going to have as transition fit. So in transition fit, you can see this is the minimum size of shaft, this is the maximum size of hole. If you are considering minimum shaft and maximum hole, you will get a clearance fit. But if you are using maximum shaft and minimum hole, you are going to have interference fit. Then it will be very difficult to make them tighten. So guys, if you have a possibility of interference fit or clearance fit, both, you will call it as transition fit. Then guys, interference fit is that in which the shaft have a minimum size more than the maximum size of hole. So in that case, you will be having the interference fit, and here it is going to be difficult to make the fit, because let us say this is the shaft and hole is smaller than that. For that, you need to tightly fit the things, and that kind of fit is said to be the interference fit. Yes. So guys, next we are talking about the allowance. So allowance is defined as the maximum material limit of hole and shaft. So guys, either it is equals to the minimum clearance or maximum interference. If we are having clearance fit, then minimum clearance is the allowance. If we are talking about interference fit, it is going to be the maximum interference. Okay, like if we have this hole and shaft, then this is the minimum clearance, this is allowance. Because maximum material limit of shaft is this, okay, and hole is this. If hole is of this size, it is having maximum material, shaft is of this size, it is having maximum material. then this gap is said to be the allowance. Is it clear, guys? So maybe some students were not aware about this session because this session is in formula series. So as per the rule, it should be only formulas. But as some topics were uncovered in marathon, so I tried to cover them in small time. Okay, so that both the things can be accepted. So this may help some of the student. Some student may be thinking why only formulas are not there. So I am doing that only for your help, guys. So try to understand this. Then we are going to have the fundamental tolerance. You know that whenever we are going to have the size, as ever the size will be increasing, fundamental tolerance will also increase. So fundamental tolerance is defined by I, and whenever we are saying IT6, IT7, IT8, they are said to be the tolerance grade. There are a total of 18 tolerance grades. Okay, so there are a total of 18 tolerance grades. I will show you that when we are talking about the tolerance grade. This is the table for tolerance grade. In tolerance grade, I will suggest you to remember IT6, IT7, IT8, IT9 and IT10. There are 18 tolerance grades. You need to remember these 5. Sometimes they do not mention that IT8 is equals to 25 times of I. They give the definition of I, but they do not define what is IT8. So you can remember that. Okay, is it clear? Yes, so always remember. Teju, for transition fit, it will be defined based on the given values. Okay, so either it is minimum clearance or it is maximum interference. There both the possibilities are there. So what you will take there? If we have that kind of fit, then what you will take? This is shaft, this is hole. So for hole, maximum material limit is this. For shaft, maximum material limit is this. This will be your answer. Is it clear? Is it clear, Teju? Okay. So guys, when we are talking about D1, D2, till date, they are always given. Okay, till date, they are always given. That whether your size is lying between which sizes. Okay, so like your size is 25, then it will be lying between 18 and 30. Okay, so if you have 40, 30 and 50, so still I will say if you want to remember, you can remember these 3 ranges. Generally your sizes are given up to 80 only, not more than that. But still I will say in 99.99% of the cases, it will be given to you. Okay, Teju, I feel you got it. Okay, so guys, we are moving further. These are the types of fit we have already seen. Now, if the tolerance are on the one side of the mean line, we are calling it as unilateral. If tolerances are there, both the sides, they are said to be bilateral. So for this type of tolerances, how we are going to write it? We are going to write it 25 plus 0.005 minus 0.001, because here we are going up by 0.005 and we are going down by 0.001. Okay, so this is said to be the tolerance case, unilateral and bilateral. Very good, guys. So now, do you want to solve a question? Do you want to solve a question? Don't worry. In the casting, we will not be requiring much time. That will be having some formulas only. Yes. You can solve this one question. A hole and shaft have basic size of 30 mm. 30 mm. Are to have a clearance fit with maximum clearance of 0.04 and a minimum clearance of 0.02. You can consider, okay, solve it with hole basis system. So for hole basis system, this is the hole. This is the shaft. They have given you the minimum clearance. They have given you the maximum clearance. Minimum clearance is given as 0.02. And they are saying that the hole tolerance is to be 1.5 times shaft tolerance. let us say this is x, this is 1.5x. You need to find out, determine the limits of both the hole and shaft. So for hole, one size is 30 mm. What is second? For shaft also there are two sizes. One is 29.98. Can you solve it, guys? Very good, Manas, Teju, Mani. Just try to solve it, guys. So this session was a mixture of marathon and formulas. So may not be suited for every student, but I tried to give it to all of you in a nice manner. Okay, because after 2-3 days you have exams, so I cannot make it very long. अरे भाई श्री राम मीना, पेपर तो देना ही है, नेगेटिविटी को खत्म करो. डियर, whenever we are talking about the exam time, ये सभी स्टूडेंट्स के साथ होता है, ऐसा नहीं कि आपके साथ हो रहा है. तो उस समय पर क्या होता है, जनरली हमारा नेचर होता है, जब भी कोई प्रॉब्लम सामने आती है हम उससे भाग जाना चाहते हैं, रादर देन रनिंग फ्रॉम इट. जस्ट फेस इट. मैंने आपसे कल भी कहा था, कल आपने शायद सेशन अटेंड नहीं किया, कल भी आपको एक बात कही थी कि इस समय पर आपको भागने की बजाय रुक के सोचना है. और मैंने आपको ये भी बताया था, ना तो ब्लेम करना है, ना ही किसी भी तरीके का आपको ये होना चाहिए कि मैंने नहीं पढ़ा या नहीं पढ़ा. अब देखो, जो हो गया उसको हम कुछ नहीं कर सकते. आई वुड लाइक टू से इन दिस जर्नी आपके साथ दो ही चीजें होंगी, या तो आप सक्सेस होंगे या तो आप लर्न करेंगे. लूज करने को कुछ नहीं है. गेट देने से आपकी बीटेक डिग्री तो आपसे वापस नहीं ले ली जाएगी अगर आप नहीं क्वालिफाई हुए तो, बिल्कुल नहीं. और अगर आप गेट दे रहे हो और मान लो आपने कॉलेज के साथ प्रिपरेशन की है, मे बी आपको समय नहीं मिला हो, तो उस केस में ऐसा नहीं है कि आपकी बीटेक उसमें अफेक्ट होने वाली है. कोई बात नहीं श्री राम, ऐसा होता है, सभी के साथ होता है. तो आप एक काम करिए, ये जो बचे हुए 4 दिन है इसको सिर्फ आप रिवीजन में दीजिए और कुछ मत करिए. आपसे अगर और कुछ नहीं हो रहा, सब छोड़ के बस आप फॉर्मूलाज को रिवाइज करिए और कुछ कुछ प्रीवियस ईयर्स के क्वेश्चन लगा लीजिए, बस इतना कर लो आप. ठीक है, बाकी लोगों ने क्वेश्चन कर लिया आई फील. तो पेपर देके आपको आना है, क्योंकि पेपर देने से आपका कुछ भी जाने वाला नहीं है. या तो आप क्वालिफाई करोगे या तो आप क्वालिफाई नहीं करोगे. नहीं करोगे तो आप जीरो पे हो, आपको लर्निंग्स मिलेगी कि क्या कमियां रही. अगर आप करोगे तो कुछ आपको मिलने वाला है. तो ये एक ऐसी चीज है जिसमें खोने के लिए आपके पास कुछ है ही नहीं, कुछ मिलेगा ही. समझ रहे हैं? तो अब जब कुछ मिलना ही हो तो जान एक ये इट इज लाइक आपको जाके प्रसाद लेके आना है. तो लेने जाने में क्या दिक्कत है, कुछ मिलेगा ही, या तो लर्निंग्स या तो अर्निंग्स. ओके, वेरी गुड गाइस, बहुत बढ़िया. सो द आंसर इज गोइंग टू बी 30.012, वेरी गुड, एंड 29.972. कैसे निकालेंगे? दिस इज 1.5x, दिस इज x, सो यू कैन से दैट 2.5x plus 0.02 is equals to 0.04, 0.008. वेरी गुड गाइस. श्री राम, आपको सिर्फ फॉर्मूलाज रिवाइज करने चाहिए और कुछ प्रीवियस ईयर गेट के क्वेश्चन लगा लो बस. हर चैप्टर में जो भी आप पढ़ रहे हो फॉर्मूला करो, कुछ क्वेश्चन दो तीन क्वेश्चन लगाते चलो. और या तो आप सब कुछ छोड़ के अपने क्लासरूम नोट्स रिवाइज कर लो और कुछ मत करो. क्लासरूम नोट्स रिवाइज कर लो A to Z, जितने भी सब्जेक्ट्स आपने करे हैं सिर्फ उतने के, और कुछ नहीं करो. अगर आप वो भी ढंग से कर लोगे तो 30, 40, 50 नंबर बहुत आराम से आ जाएंगे, अगर आपको कुछ नहीं आता तो भी. ठीक है, डिपेंडिंग ऑन योर लेवल ऑफ प्रिपरेशन. सो गाइस, जैसे आप देखो इस क्वेश्चन में आपको दिया हुआ -5.5 d to the power 0.41. दिस इज द फंडामेंटल डेविएशन. ओके, इस तरीके से देते हैं. सो गाइस, नाउ वी आर टॉकिंग अबाउट द टॉलरेंस सिंक. आई फील आप सभी लोग जानते हैं, whenever a component is made up of 3 parts, then they will be providing you the sizes of 2 parts, and third part will be treated as a tolerance sink. So guys, if you are given one question on this, that will give you the better idea. Let us say we are going to have one component like this. This is P, this is Q, this is R. P, Q, R. And this all and all is said to be S. And all are given the sizes like this. So guys, if you want to find out the maximum size of R, let us say P is given to you, Q is given to you, S is given to you. It will be S max minus P min minus Q min. Arey bhai, R will be maximum and these two will be minimum. If you remember, in the class I have taken a wonderful example for this, where I have given you the example. If I am going to give the prize to the student who are going to solve the question, and let us say you are going to solve 3 to 4 students together, how you will divide that money into each other. That was the wonderful example I have taken at that time. Okay. So this is the way to find out maximum size and minimum size. Now dear, I would be telling you about the gauges like Teju was asking. This is, I feel, the last heading where I am going to explain something, because otherwise the casting formula will not take much time. Okay. Welding we have covered, machining we have covered, metal forming we have covered, sheet metal operations we have covered. So guys, only casting is left for the formula point of view. Whenever we are talking about the gauges, as you know my dear, whenever you are going to make the shaft and hole, you are not going to get shaft and hole of the desired sizes. So if shafts and hole we are not able to make the desired sizes, to measure or to inspect the size of shaft and hole, we are having some gauges. And those gauges are said to be go and no-go gauges. Let us say, if you want to make a 50 mm shaft and the desired tolerance is, the acceptance is 49.995 and 50.005. So this and this sizes, this is the range of acceptance. Customer says, I want a 50 mm. That is also their money. Customer says, I want a 50 mm shaft and hole, and for 50 mm shaft and hole, this is the desired tolerance. This is the acceptance limit of the customer. So if this is the accepting range of customer, my dear, from 50 mm shaft, this is the desired tolerance. Then my dear, I will be checking these two sizes. So I know that all the components, like let us say I am talking about shaft right now. So to inspect the shaft, we will be having the gauges known as ring gauges. Those gauges are of hollow kind. Then only it will be able to inspect the shaft. So those ring gauges, one gauge will be having this size 49.995. So as this gauge is of hole size, this is of hole type. So if any shaft is going to pass from this, it means its size is less than 49.995. So any shaft which is coming in this range shall not pass from this. So the size of the gauge 49.995, this gauge will be said to be no-go gauge. Because from this shaft shall not pass. If it is passing from it, its size is lesser than that. And my dear, when I am saying 50.005, from this, if any shaft is not passing, it means its size is more than that. So any shaft which I am selecting, if it is passing from it and do not pass from it, will be selected. So this will be our go gauge. So this is when I am making a 50 mm shaft. Now in the second part, if I want a 50 mm hole, if I am looking for a 50 mm hole, then my dear, for that, if I am looking for 50 mm hole, and once again these are the desired sizes 49.995 and 50.005. To check a hole, we will be having a gauge of shaft size which is said to be plug gauge. This is of shaft type. To check the hole we have shaft, to check the shaft we have hole. And if we are going to do that, this time my dear, if our gauge is of 49.995 and if our gauge is able to pass from this hole of 50 mm, it means the size of hole which we are taking is going to be more than that. It should be more than that, so this will be go gauge. And similarly on the same logic, it will become the no go gauge. Everybody understood that or not? Please tell me that. Everybody understood this or not? Please tell me that. Yes. Mani, Teju, Ayush, Manas. Fine, guys. So now the point is, when we are going to make the gauges, like we were unable to make the exact size of shaft and hole, we are unable to make the exact size of gauges also. So in gauges also there is going to be some kind of deviation, some kind of tolerance. But the problem is, with one gauge we are going to measure thousands of shaft and hole. So if we are going to use some advanced machines for gauges at least, then we can have at least lesser tolerances in the gauges. So in general, the tolerances used in the gauge are said to be gauge tolerance, and that is found out to be 1/10 of the work tolerance. So gauge tolerance is 1/10 of the work tolerance. 1/10 of the work tolerance. Sri Ram, now the time is very less. It is your choice whether you go by marathons or you go by your notes. Both are fine, but you shall go for revisions. Nuksan fayda kuch nahi hai. Now you can go for the revisions. That will be better. And better you will connect with me after the class so that I can help you better. Okay. Teju, work tolerance means this one. This one is work tolerance. This one is work tolerance. If this is 50.005 minus 49.995, this is the work tolerance. 1/10 of that will be the gauge tolerance. Is it clear, Teju? Is it clear, Teju? Is it clear, Teju? And as we are talking about in the go gauge, every time the passing will happen, sometimes we need to provide the wear allowance on the go gauges also. So when we are talking about the wear allowances, that is equals to 0.1 times of, or you can say 1/10 of gauge tolerance. So wear allowance will be provided on the go gauge, but not always. Only when work tolerance is more than 0.1, then only we will be providing. But as I said, this type of question will not be coming in GATE. If you see the syllabus, they have not mentioned now the gauge design. So chances are very less that question will come from it. But it can come, but not up to that level that you will be having all those kind of discussion required. Okay, gauge tolerance, add to lower limit or upper limit. That I am telling you. Guys. So for that, I would like to tell you that there are 3 types of gauge design. First type of gauge design is workshop gauges. So one is said to be workshop gauges, second is said to be inspection gauges, third is said to be general purpose gauges. So when we are talking about workshop gauges, here it is similar to the army. Selection is similar to the army. In this kind of selection, we will definitely accepting good components. And there is no chance of accepting bad component. You have seen some persons are getting selected into army after 5 attempts, after 3 attempts. What do you mean by that? If they were selected after 3rd attempt, it means they were fine. They were good candidates. But why 3 attempts? Because they are not taking any chances. Like if I am not taking any chances, sometime I may not be able to get the good components. Sometime good components will also be skipped. Like if I am going to make a batch of 20 students only, and I am going to make a test for you guys, and in the test maybe some of the students was not able to perform well because of some health issue and all. But I am not taking any risk. That student comes, sir, I am good student, please take one more test for me. And I will say, no, you can appear for the next test after 6 months. So he was that much crazy. He have given the test next time and he got selected in that. So he was a good candidate, but still was not selected in the first attempt because I am worried about the quality. I may reject some good component, but will not accept any bad component. So here in the army, this is the procedure. But in IT companies, whenever they come in the colleges, they take any student like that. Because they know if some candidate is not good, he will be automatically going out from the system after training. Because their cost is nothing. In army, if bad component will go, the cost is very high. Okay, so that is why in inspection gauges, we are saying we will not leave any good component. Maybe because of that some bad components comes in the system. So both have different philosophy. And my dear, how we will choose the sizes? First of all, we are talking about this. You can see this is the hole. So if you are checking the hole, you can see this size was 50.005, let us say, and this size was 50. So this was the desired tolerance. So when we are talking about the first type of gauges, which are workshop gauges, then my dear, you can see for no-go, we are going to have these two sizes. So the size will be 50.005. And you know, 0.005 is the work tolerance, Teju. So gauge tolerance will be 0.0005. So this size will be 50.0045. So this is for the no-go gauge. And for the go gauge, it is going to be 50.0005. And this is the wear allowance. We are not always providing. So you can skip this also. But if you still want to take that, then this size will be 50 point. You know, this is 0.005 minus 0.00005. So this is about the workshop gauges. So if you want to be clear where to add, where to subtract, you can see this. For a whole, this is no-go gauge, this is go gauge for workshop philosophy. For inspection philosophy, we are allowing some bad parts to come in because we don't want to lose any good part. You may be thinking, sir, why we are losing the good parts? Because if you are going to have a size of this, then my dear, this much part is going to be rejected. So because this much part is rejected, some good components will not come in. So that is why in workshop, in army selection, some good components, some good peoples are rejected. But in IT companies, some bad peoples are also coming in the system. So that is the reason. And my dear, whenever we are talking about general purpose, here go gauge is taken from the workshop gauges, no go gauge is taken from the inspection gauges. Is it clear? Teju, samajh mein aaya? So this is how we are going to select it. This is for the whole. And if you are measuring the shaft, then you know go and no go will be replaced. Now this will become go, this will become no go. Wear allowance is not always provided. I told you for wear allowance, we need to check what is the gauge tolerance, what is the work tolerance. And if it is going to be more than 0.1, then only we provide the wear allowance. I feel now you got it. This was about the gauge design. And I feel now all these things, there is no formula. So we need not to go for these things. Okay. But I will share you this so that if you want to revise it, you can do that. Sir, in question type is not mentioned which is used, which to use. Then you will go for general purpose. Sujesh, if nothing is mentioned, you can go for general purpose. Okay. Or you can go for the previous year's question. If you see, there you will get how they are getting solved. You can follow that. Okay. So guys, now we are talking about this average formula. That also I have done a question. H maximum is F square upon 8R. So in the metal cutting session, sir have also discussed that when to use F square by 8R, when to use F by 10 CS plus code C. That also I feel it was discussed already. Now my dear, we are going to enter into the computer integrated manufacturing. So please tell me guys, Teju, plating is nothing but it is plating में क्या होता है? Just एक outer layer चढ़ जाती है. In plating you are just going to have outer layer. So that can be very easily understood by the question. Okay, if you share the question, I will tell you very easily. Okay, because you are having the doubts in those questions. Plating is not something which I will tell you here. What is that? One layer is going to be coming, and based on that layer the sizes will vary. So better we will see that with the help of a question. Okay. Okay. Yes. So guys, now for computer integrated manufacturing, you already know that what are the advantages. Here also I will be going with the formula. So do you want me to quickly revise it or shall we go for the formulas only? Yes. For computer integrated manufacturing, do you want some revision? Shall we go for it? Or only the formula? Because formulas are only two here. Basic length unit and velocity of tool. Okay. Yes. Okay, very good. Formulas and code. So first of all, I am going for the first type of transformation, that is translation. For translation, this is how we are going to define the matrix. It can be defined in vertical format also. x1 y1 is equals to xy plus tx ty. Translation in x and translation in y. Second is the rotation. Like we are already having a point P which is rotated by an angle of phi. Then my dear, you can write it as x dash y dash as xy into cos phi sin phi minus sin phi cos phi. Then in the scaling, we just need to multiply it with the matrix with Sx and Sy. Reflection, you already know. If we are going to have a reflection of this point about y-axis, it is minus x comma y. About x-axis is x comma minus y. About a line y is equals to x will be y comma x. This is how the reflection is being seen. Then you know that the next formula for this is BLU. That basic length unit is given by this. Basic length unit is, it is equals to pitch divided by ns, the speed of stepper motor, into gear ratio. Actually, this is not speed. This is the number of steps. Number of steps per revolution. This is the pitch. This is basic length unit. The distance traveled by table tool for one pulse or one step of revolution. Then my dear, you already know these things. I have defined it in a nice manner. Now we are talking about the codes. So you can see the codes. GR is gear ratio, Sujish. GR is gear ratio. Ha, Teju, steps and pulses are same. Because for one pulse, one step is the angle or step rotation by the stepper motor. Then my dear, G00 is for rapid traverse. Rapid traverse means if your cutting tool is somewhere else, it will be coming back without any cutting operation. Then we have linear interpolation. It is cutting in the linear path. Then circular interpolation clockwise, circular interpolation counterclockwise. Dwell means holding for a particular known time interval. 05 is holding. Okay, holding. That is acceleration 08, 09 retardation. 70 is inch programming, 71 metric, and 90 is absolute positioning. Okay, and then we are going to have G91, incremental system, and G92, reference point system. I feel everybody is aware of the meaning of these. Then M codes are the miscellaneous. Sujesh, definitely gear ratio will be given to you. Then only you can solve it. M02 is the end of program. M03 starts spindle speed clockwise. 04 anti-clockwise. 05 stop spindle. Tool change. Coolant on. Coolant off. Both coolant off. G codes are necessary functions. This is miscellaneous function. Okay. Is it clear? Everybody is clear with that? Fine. So these are the G and M codes. I have kept only those codes which you shall remember. Remember the Kane cycle because these operations are always done together. Drilling, boring, reaming, and okay, cancelling. Moving further, APT language. So for APT language, we have some geometrical statement. Like point can be represented as P 2, 3, 4. Then you can also write it as point as intersection of L1 and L2. Okay. Similarly, we can show if you want to go from one point to other, from 2, 3, 4, go to this. Go LFT, go RGT, go up, go down, go forward, go backward. Okay. Then we have post processor, coolant on, coolant off, spindle, RPM, anti-clockwise, feed rate 20 mm per minute. Then compilation is fini for finish and for stop. Okay. Is it clear, guys? In non-conventional, you know, whenever we are going for non-conventional machining, We go for non-conventional whenever conventional we are not able to do. Why? Because in conventional there is a principle that cutting tool should be 30% more harder than workpiece. If we are having workpiece to be more harder, we cannot go with conventional machining. So guys, second thing is physical contact. Whenever we do not want, then also we cannot go for the conventional machining. If you want very nice surface finish, you cannot go for the conventional machining. So for all those reasons, we need to go for non-conventional machining. If you want excellent surface finish, if you want intricate, some very difficult shapes which are very difficult to produce by conventional machining, you do not want any contact, then for such cases you go for non-conventional machining. So when we are talking about EDM, for EDM, my dear, this is the formula for discharge voltage. VD is V naught 1 minus e to the power T by RC. R is the resistance, C is the capacitance, T is the, actually it is T1 which is said to be the charging time. But T1 is nearly equals to the cycle time. So even you can consider it the charging or cycle time. Because you know that capacitor are going to charge for some time and then discharge. Is it clear? Very good, Teju, for micro holes also. Everybody remember this all? Then my dear, after derivation, you can also get the time formula as RC ln V naught by V naught minus VD. VD is the discharge voltage, V naught is the optimum one. Then frequency is 1 by T. So frequency can also be written. Then power. Power is energy by cycle time. So you can write energy as half CVD ka square divided by cycle time. You know the formula. Okay. So when you know the cycle time formula, we have just derived in the previous slide. That is nothing but RC ln V naught by V naught minus VD. After getting the formula, you will be getting the average power to be this. And if you will go for the maximum power, it will be coming out to be a voltage as 0.72 times of maximum voltage. I feel everything I have given in this formula. Is it clear? So then we are going for ECM. What are the formulas used in ECM? In ECM, you know, I can be written as Q by T. Q by T. Charge by time. So you can write Q is equals to IT. Okay. Then we are writing actually, whenever we are writing Q is equals to IT, Q is equals to IT, then you know the mass displaced is directly proportional to charge. So it can be written as equals to ZIT. Here Z is electrochemical equivalent, which is given as E by F. F is the Faraday law, Faraday number. So guys, that Faraday constant is 96,500. Then weight is given as EIT by F. Now what is E? E is chemical equivalent given by atomic weight but a valency. If nothing is mentioned about iron, the valency you can take as 2. Iron shows 2 and 3 both valencies. If nothing is mentioned, you will take the valency as 2. Okay, very good. So guys, there is second formula for the MRR in gram per second. So if you want to find out MRR in gram per second, it will be W by T. It will be EI upon Faraday law, Faraday number. Okay, then you can also find out MRR in centimeter cube per second. For that, it will be coming out to be EIT by F rho T. TT will get cancelled out. EI by F rho is the formula. Okay, I feel everybody remember that. Specific MRR is EI by F rho I. II will get cancelled out. So E by F rho will be the formula. So ECM for alloys, for that you know you need to find out 1 by E as equals to X times valency 1 by atomic weight 1 plus Y times V2 by A2 and so on. What is X? X is, it will be 0.18 if we have 18% of first element. It will be 0.25 if we have 25% of second element. So likewise, X and Y will be defined. E is atomic weight by valency. Very good, guys. So in All others, you know, there is no such formulas which are majorly coming. Okay, this is for nozzle tip distance. Okay, I feel next we have covered. So for casting, the first formula is for permeability number, which is VH by delta P 80. Always remember, here V is volume in centimeter cube. Here delta P is gram per centimeter square. Here time is in minute. Always remember that. And always remember this area sometimes is not given. 20.28 centimeter square. H is equals to diameter is 5.08 centimeters. If you remember, it was as per the standard AFS. Okay. Then you know, for gating system, we have the first formula as for top gating system, gate velocity is root 2 GHM. For this, we have already taken the marathon. You can go for it if you want. Okay. So here I am just telling you the formulas. Then we were having a formula for top and bottom gating system. For top gating system, the formula is area into H divided by AG into 2GHM. Height of molten metal. This is for top gating system. For bottom gating system, this is the formula. Here HM is the height of molten metal and H is the height of cavity. If this cavity is becoming equals to HM, then this formula will become this. Then bottom gating system will take the time 2 times the top gating system. Okay. Then you know that, my dear, choke area is given as M divided by rho TF CD 2GHM. Okay. Then you know that, guys, the next is for riser design. The formula is K times V by SA ka square. Is it clear, guys? Then we are talking about the core. For core, the formula net force is PM minus PS into VG. Here PM, actually not PM, it is rho M. I am telling you that. Whenever we are going to find out the net force on the core, it is density of molten metal, density of sand into volume of core into G. This is the net force. Is it clear, guys, for everyone? Yes. So for this also, you know, I feel so that solidification time is K times thickness ka square. So you can write thickness is C1 times solidification time plus C2. You will use this relation for slush casting. And for centrifugal casting, you will be considering outer diameter as they have asked in here. R will be R outer for acceleration to be maximum. Is it clear, guys, for everyone? Please tell me that. Bolo bhai, I know some things I have gone through very fast because this was a formula revision session. This was not a marathon. But for your request, I have kept some topic as marathon. So this was just only for your request. Otherwise, it was not a that kind of session. Now, dear, this is a sincere request from my side to you. If you want anything else for your preparation, any formula, any type of question, mention it in the Telegram channel or on the WhatsApp group or message me personally. In the next 2 days, I will provide you that. Because after that, last 2 days, you have to give revisions. And I don't want to see you at any other platform, at any other place. Just you, your notes and revision, nothing else. Okay, yes, if you feel some pressure, if you feel some refreshment is required, go for meditation, go for listening to good music, but don't divert your mind. Maybe some people will be coming gate exam, cancel, that kind of news also on YouTube. Just things are going on. Don't waste your time for such things. Just concentrate on the exam. Okay? Okay, so take care of that. Don't worry, Teju, for P&I will be there, for XC will be there, then for engineering services will be there, then for BARC will be there. We are not going to stop, okay? As I said, until you will be getting to some place and you will be getting some good opportunities, we are going to help you till that point. Okay, so after that we will be coming for XC also, PI also, ESC also, and then we will be coming for BARC also. So goodbye for this session, guys. Thanks for joining and thanks for your love and support. Before leaving, just like and share the session so that others can also be benefited from it. Goodbye.